Agarwal ji, Principal Deshbandhu College, Dr. Praveen Damaje, Advisor Skill Council and Green Job Government of India, Professor Kamal Gupta sir, Vice Principal Deshbandhu College, Professor Devnandan sir, Teacher in Charge Department of Chemistry, respected speakers of both the session, Professor H. Ila, Dr. Khushbu Kushwa, Professor Shivani B. Mishra, Dr. Sumati Bhatia, our senior faculty members, fellow colleagues, and dear students. I wholeheartedly welcome you all to the today's International Symposium, Chemical Wisdom by Her. From the eye of a chemist, she could be expressed as a carbon. She is a part of every one of us, from low to high, from the hardest substance to the dazzling diamonds. She has a unique capability of empowering everyone. Well, contribution of women in science and technology is not only important in enriching their lives, but are contributing towards promoting well-being of the community and the nation as a whole. So, as women, we must believe in ourselves or no one else will believe in us. We must match our aspiration with the competence, courage, and determination to succeed. Therefore, it's necessary to make our dream, our life, a reality. This reality cannot be attained without the blessing of Ma Saraswati, as it's our tradition. Before starting any event, we offer prayer and take blessing of Ma Saraswati by lighting the lamp to the goddess of knowledge. We therefore embark the opening of our program by virtual lamp lighting. I would request Dr. Leena to play the video, please. As we all are blessed now, let's move on to our today's program. Now, I would like to invite Professor Devnandan sir, teacher in charge, Department of Chemistry, to say few words and begin the symposium. Over to you, Professor Devnandan sir.
Good morning to one and all present here. On behalf of Department of Chemistry, Deshbandhu College, I welcome Professor Balram Pani, Dean of Colleges and Chief Guest of today's program. Professor Rajiv Agrawal, Principal, Deshbandhu College. Dr. Praveen, Advisor, Skill Council of India. Distinguished Vice Principal, Sir, Professor Kamal Gupta. Faculty members, students, and participants. Now I welcome Professor Rajiv Agrawal to address the gathering. Over to Professor Rajiv Agrawal, Principal, Deshbandhu College.
Thank you, Professor Devanandan. Our chairman sir is also here. So we welcome him as well. Chief
I'm
guest of the
sorry. I welcome also Honorable Chairman Sri R.N. Batsar.
Thank you. Chief guest of the event, Professor Ram Pani, Dean of Colleges, University of Delhi. Chief patron of the symposium, our Honorable Chairman, Governing Body, Shri R.N. Vasji. Participants from all across the globe, our distinguished speakers, and all dear colleagues. I welcome you all on behalf of entire Deshbandhu College fraternity on the academic occasion of an international symposium, which is organized by Department of Chemistry on the topic Chemical Wisdom by Her, under the aegis of IQAC. On this platform today, we have amongst us Professor Balram Pani, Dean of Colleges, University of Delhi. Professor Pani, however, needless to mention, has been instrumental in making all the promotions happen in the university, apart from implementing other significant academic transformations. We welcome you, sir. It gives me immense pleasure to welcome Shri R.N. Vasji, our Honorable Chairman, Governing Body, Deshbandhu College. Shri Vasji has been supporting pillar since he assumed the chair a little more than a year ago. I welcome our distinguished speakers, Dr. Praveen, Dr. Hiriyak Kanawar Ila, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, Dr. Khushbu Kushwaha, Associate Managing Editor at Wiley, Professor Shivani B. Mishra, University of South Africa, Dr. Sumati Bhatia, Freya University, Berlin. Friends, as indicated by the topic, this symposium not only helps in enhancing our scientific knowledge, but also empowered women and acknowledge the great role of women in science and technology. Such events also facilitates the younger generation of women to actively get involved in research and higher studies. As Mahatma Gandhi once said, when a man is educated, an individual is educated. When a woman is educated, a family and a country is educated. Women have contributed to chemical sciences since the ages of alchemy, and this is the time to acknowledge their contribution and celebrate women scientists' achievements. The contribution of women scientists in the field of chemistry, more than well known in history now, what began with Marie Curie, twice Nobel Prize winner, the first ever to achieve the feat, but continued with Ada Nodak, Anna Harrison, Rosalind Franklin, Mildred Cohan, Darlens, C. Hoffman, amongst others. The list also proudly would include our own female scientist, Padma Bhushan C.V. Raman and Bhatnagar awardee, Dr. Ashima Chatterjee, whose fundamental contribution for development of anti-epilepsy and anti-malaria drugs is internationally acknowledged. The more progressive we become in the field of chemical sciences, the more scope there is for the women to come forward and contribute. I hope this symposium, within its goal of academic focus, will try and draw our attention more to that end, encourage and inspire us to do better. I also hope that through this symposium, students get motivated to go for higher studies, especially in the field of research. Before I conclude, I would like to thank the organizers of the event, especially convener Dr. Pratibha Kumari, teacher in charge Professor Devanandan Kumar, our Vice Principal Professor Kamal Kumar Gupta, our IQAC coordinator Dr. Aditya Saxena, co-conveners Dr. Ashita Malhotra, Dr. Seema Lal, Dr. Leena Agarwal, organizing secretaries Mr. Sanjay Kumar, Dr. Ashwini Kumar Singh, Dr. Mathu Moran Singh, and all the colleagues and students at the Department of Chemistry for organizing the wonderful symposium and wish the event a grand success. At last, I convey my best wishes to all the women scientists who has been actively involved in this symposium. Thank you. Over to you, Devanandan.
Thank you, sir. Now I am inviting Professor Balram Pani to say few words and address the gathering. Professor Balram Pani.
Thank you, Professor Devanandan Kumar, the teacher in charge of the chemistry. And very good morning to you all. R.N. Basti, the Honorable Chairperson of the college, Professor Rajiv Agrawal is the Principal of the college, and the eminent personalities and the distinguished guests, Professor Ella, Professor Srimati Bhatiaji, Professor Kuswaji, Professor Shivani B. Misraji. Means it is good to have the symposium in the chemistry department. They are organizing the international symposium. It is the need of the time. And to me, since I am from the chemistry background, and your topic is the chemical wisdom by horse, it's a good topic. And whenever there is a symposium or seminar, webinar, whatever it is, to me particularly, food without salt is similar to the academics without the symposium. So more frequently, such type of symposium or seminar or webinar should be carried out. And the chemicals means right now you have talking about the chemicals. First of all, we'll have to know that what is the chemical. The meaning of chemical is of relating to, used in, or produced by the chemistry, or the phenomena of the chemistry. And right now here, the chemistry, whenever it is producing the chemicals, now it is the duty how to use the chemicals in the substances. And the chemistry, and first of all, what means before going down to the chemicals, then you will have to go for that. What is the chemistry? Chemistry is defined as that the branch of the science deals with the study of elements, compounds, matter, the composition, the structure, properties, nature, fate of the chemicals, or fate of the elements of the compounds in the system. And the changes the chemicals, so whenever it is coming out, different conditions, and they are bound to follow certain laws. Means are always law-abiding people because the chemistry always followed by certain laws, and these are the things you are doing well. And the chemistry is very important. It is important because everything you do is chemistry. Even your body is made up of chemicals. Chemical reactions occur on in your body. All the matter is made up of chemicals.
Facing the network issue.
It looks like some network issue.
I think there is some network issue.
Yeah, that's, yeah.
Wait for a moment.
Hi.
Sir, I think sir is saying something.
I think these are the glitches of today's technology. So at times we are just stuck. Maybe sir is going to join
Hello,
again.
am I audible?
Yes, sir, now you're audible. Yes, sir, now you're audible.
Okay. No, that is the importance of the chemistry I'm talking about. That and the nuclear atomic application in the industry.
due to network issue, your voice is breaking, sir. Internet issues. Yeah, we are not able to hear you.
Ashna madam, I think there's some technical
Yeah,
issue.
looks like
So,
it needs there's a technical issue. So maybe we'll
So
just
it's like
yeah.
as the Professor Pani was saying, like it's all chemistry. So our body is chemistry. Everything is going around chemistry. So it was very nice that he was talking about the importance of chemistry. We are which we are seeing everywhere, starting for us and in the surrounding. So it's always we can relate everything to the chemistry, whatever we are using, and all the biological reactions. I think he was trying to say something about nuclear chemistry now. So there is some problem. So we can wait, or we can request
I think, Dr.
teacher in charge or the principal sir to
We can
like
Yeah,
say few
as
words.
to guy. Yes.
Yeah.
request our chairman, sir, now. Because
Okay. All right, sir. Maybe sir is going to, Professor Mani is going to join again. So now I would request our chairman, Mr. Aaron Westji, to say a few words.
please unmute the chairman, sir. First बनाइए.
साहब को होस्ट तो है ना?
Chairman, sir, may we request to address the gathering now?
चेयरमैन सर.
हेलो.
हाँ सर, एड्रेस कीजिए चेयरमैन सर.
Thank you, Professor Devanandan. Thank you. Professor Rajiv Agarwal, worthy principal of our college, Professor Kamal Gupta, our vice principal, Professor Devanandan Kumar, teacher in charge chemistry department, and all the participants of the symposium. First of all, I congratulate and give my sincere wishes to the Department of Chemistry for organizing such a important symposium, for which will give benefit not only to our student but to the public as well, who will join this symposium. The Department of Chemistry in our college is very active in organizing such activities under the leadership of our principal, Professor Rajiv Agarwal. I must congratulate the teacher in charge, Professor Dev Nandan Kumar, to organize such an international event, which will definitely benefit the teaching community as well as our dear students. I hope the seminar and its proceedings, especially I came to know that women scientists are participating in this seminar. Women are now ahead of the men. They are doing all the great things in the country, including academias. I once again congratulate and I seek permission not just to withdraw myself because of my commitment in High Court for 10:30 at some important case. Thank you very much for inviting me. I heartily welcome all of you. Thank you very much.
Thank you, sir. Thank you for your kind word, inspiring us to dream more, learn more, and do more. Now, I would request all the dignitaries to launch e-booklet of Symposium. For this, we would like to invite our chief guest, Professor Balram Paniji. Looks like he is not connected. Dean of College, University of Delhi, Mr. R.N. Vasji, Chairman, Deshbandhu College, Dr. Parveen Dhamaji, Advisor, Skill Council for Green Job, Government of India, Sir Professor Rajiv Agarwalji, Deshbandhu College, Professor Kamal Gupta, Sir, Vice Principal, Deshbandhu College, IQAC Coordinator, Dr. Aditya Saxena, Sir, Professor Devanandan, Sir, and all the senior faculty members of our college. Please do the honor. Dr. Leena, could you please share the booklet
So, Dr. Ashna, what will you do?
Yes, sir.
Here, the release of this abstract book of this symposium. Congratulations to the chemistry department.
You're not audible, sir. Sorry.
Am I audible now?
Now you're audible, sir.
All right. Congratulations to the chemistry department and all the members who were behind this abstract book and this symposium. Congratulations to all.
Thank you. Thank you so much, sir. Thank you for all of you, Sir Professor Rajiv Agarwal, Deshbandhu College, Sir Professor Kamal, sir, Deshbandhu, IQAC, for launching this e-booklet. This e-booklet is compiled of all the hard work of our participants across the globe. And all the participants have presented their poster in front of the judges yesterday. Indeed, it was a great work by all the participants. Thank you for launching of our e-booklet, sir. Thank you, Professor Balram Pani. Thank you, Vatsji. Thank you, Professor Rajiv Agarwal, Kamal Gupta, sir, Professor Devnandan, sir. A sincere gratitude to all the dignitaries. Moving on, now we would like to invite our Dr. Parveen Damaji, who had served as Scientist G in the Ministry of New and Renewable Energy, Government of India, currently working as advisor in Skill Council for Green Job and providing skill development in various sectors of renewable energy and environment sustainability, like green construction, green transport and all, and water management. Ma'am, we are waiting to hear you. Please address the gathering. Over to you, ma'am.
Dr. Reena is making host, so just wait.
Ma'am, hello. By which name she has joined?
Maybe Dr. Parveen?
Dr. Parveen Damija,
She has joined.
a co-host बना
Reena, please make her co-host.
Yeah, now it's okay. And okay, yeah. So good morning to all of you, respected chief guests, learned speakers, and your faculty and students. My link to this conference is an invite from Dr. Pratibha, and I'm very honored to be here. And I also think it's a great opportunity for me to interact with this learned fraternity of students and faculty. As you see, I would like to focus, like you say, women in science, women in so many things. Women are the pivotal role. They have a very pivotal role in our society. And as you see from time, times immemorial, or we see as we progress, women have started, they have a lot of say, or they have a lot of participation in technology oriented education. We have a lot of scientists, we have a lot of engineers. And if you see the statistics, women graduates are almost 43%. But then when you see the jobs, they come only at 14%. So why is this? Why we don't have women who are there in the jobs? Why women don't take up jobs? So don't you feel that in addition to taking up the education, women need to be promoted, or women need to be nurtured to take forward the education, to take forward the technology they have acquired. When I was a student, I also specialized in microbiology. That was almost 3 decades back. I was discouraged. I was told, you take botany. I said, no, I'm interested in microbiology. I will take microbiology. And I tell you, this has been a long inning in the ministry. But there also, I was only one, 70 male officers and one woman scientist all along. So women have to be encouraged. You have the faculty or you have the stream of doctors, teachers, but where are the women who are there actually in the administration? They are not there. Why? Because we need to connect with them. We need to nurture them. Government of India has taken so many initiatives. We have the schemes from Department of Science and Technology, where we look forward to promoting women from rural backgrounds. They can take up, they can connect for higher education. But the thing is that we have to connect. I was doing a project in one of the villages, in 100 villages in Haryana, and we visited a school. And when I asked the girls what they would like to be when they grow up, or what line of profession they would like to take, most of them said, we want to be teachers, school teachers. So that connect is missing. We have to go and connect with them. We have to tell them that these are streams which you can take up. And if there is some problem, or if there is some, they don't have some economic background or economic backing, or even from the family, we have to convince them that, no, this is also a stream where you can come up. You see, your Marie Curie, you see those Nobel laureates who have taken so much of, they have so much of recognition in this field in which you are promoting. Chemistry was one of my favorite subjects also, organic chemistry, but I opted for microbiology. So when we have so many things being going on, initiatives by the government of India in terms of even for opportunities for where there's a career break with women who do not take up education, who do not take up careers, or who, because they have to look after family. I can just quote one recent Dr. Our president had said that in this COVID, women have got now 3 burdens. One burden is they have their profession. Second burden was the domestic responsibilities. And a third burden is of educating the children. So women, when I take myself as an example, I know how during all the stages in my life, I had to balance my work. I had to balance my, profession, my home. And it was a big struggle. It was not easy. And then coming up among a fraternity of men, that is the biggest challenge. So we have to encourage each other. We have to look after each other. Being single, you have a very lonely career. You are most of the time you are out of the mainstream, and you have to really push yourself when you have to be in the mainstream. So I feel that women, they have come up a lot, but they need to be pushed further. The POSH Act, which is the latest, you can say, that is something which is really giving us protection at the workplace. I have dealt with many cases where women had the courage to come forward, and they could tell us that, yes, there is a problem in my workplace, but it takes a lot of motivation. So security, safety at the workplace is also something which has to be promoted, which has to be taken care of. When I was doing my PhD, my guide was so possessive about me. He always used to say, don't do this, don't stay here, don't go there. So that's sort of why should that be there? Why shouldn't a woman be so confident that if I stay late in my lab, I am safe? So these things also have to be introduced, and these things have to be told to the women that this safety is there. So I would like to conclude here. Women, they are there. In the renewable energy sector, we are getting so many women who are coming up, but then again in the workforce for decentralized energy systems. In rural areas, you can see so many women taking up entrepreneurship, taking up role model skilling activities. We do in this, we are promoting women for skilling as trainers, as trainees. And again, I would like to share, as trainers, women are not encouraged. There was a course we did on solar training. There was only one girl. I always look for women when I do a training. And she told me, ma'am, I was being, discouraged from taking up this training. I want to be a solar installer. But luckily, there are organizations, there are companies which are coming forward, which are taking it forward, and which are providing more incentive to women. If you take Renew Power, which is one of the largest organizations in India, and of course, having international projects, there the whole team for solar installation is of women. So this is the type of spirit we should have, and we should encourage, we should push, we should motivate and facilitate. So I feel this conference is, of course, the biological functions and the chemical functions are old day, but those chemical functions have to be motivated. They have to be pushed. Women have to be told, I've come across a girl who was doing engineering. She didn't want to go home because her parents would get her married. She wanted to take up a career in civil services. See the agony of women who are acquiring higher education, who are educated, but still they are not able to take it forward. So I feel you people from the colleges, from the university, you should have groups who should motivate and see that the women who take up education, they are put in good places where they can contribute. We were 16 girls when I was doing PhD, and all 16 of us today are in very good positions. They are in very good positions. They have contributed a lot, not only to their family, but they have also contributed a lot to society, to the national level. They have one of them, some of them are doing very well internationally also. So this is my request. You people should connect, you people should facilitate, and you people should motivate and provide support wherever possible. I wish all success for this deliberation. And I'm again very thankful to you for giving me this opportunity to connect with students and connect with all of you. Thank you very much.
Thank you so much, ma'am. Indeed, it was really nice. And you said so practically that why the number of girls are low in the science field. Really, ma'am, thank you for enlightening us with your words of wisdom. Now we would like to invite our ever-smiling and energetic Vice Principal, Professor Kamal Gupta, sir, to address the gathering. Over to you, Professor Kamal Gupta, sir.
Good morning. Am I audible?
Yes, sir. Yes, sir.
Good morning to one and all present here. A bright, sunny day. And so the theme of the conference, International Symposium, Chemical Wisdom by Heart. I welcome on behalf of Deshbandhu College, as well as on my behalf, respected Chief Patron of Deshbandhu College, Governing Body Chairman, Shri R.N. Vats, Chief Guest of the day, Professor Balram Pani, Dean of Colleges, University of Delhi, Patron, Professor Rajiv Agarwal, Principal Deshbandhu College, a dynamic, versatile, energetic, visionary, and who is giving altogether a new path of progress to Deshbandhu College. Our guest of honor, Dr. Praveen Tamija, Advisor, Skill Council for Green Jobs, Government of India, IQAC Coordinator, Dr. Aditya Saxena, DBT Star Coordinator, Dr. Indrakant Kumar Singh, delegates, participants, eminent speakers for this conference, Professor Ila, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, Dr. Khushbu Kushwaha, Associate Managing Editor at Wiley, Professor Shivani B. Mishra, University of South Africa, Johannesburg, and Dr. Sumiti Bhatia, University of Berlin, Germany, delegates, participants, students, faculty members, senior faculty members from Deshbandhu College, University of Delhi, various universities of India and abroad. It's really a proud moment here at Deshbandhu College that chemistry department is organizing an international symposium on the topic Chemical Wisdom by Her. I congratulate chemistry department who is versatile, who always take initiative, who really is shining in the research. My heartfelt congratulations to teacher in charge, Professor Devanandan, convener of the conference, Dr. Pratibha, senior faculty members, newly appointed professors, at least 3, Professor Sushila Singhal, Professor Mahesh Meena, and Professor Ruby Mishra. Applaud and appreciation. Congratulations for this. If I say chemical wisdom by her, probably, I don't know why we have reached to a state where women need special mention, recognition. Our Hindu religion, right from day one, say, if we talk of power, we remember Kali. If we remember education, knowledge, we remember Saraswati. If we talk about the prosperity, we remember Mahalakshmi. We always take off Mother Earth. We always take off the countries whenever motherland. But unfortunately, whenever we talk about the father of biology, we talk of father of chemistry, we talk of father of immunology. So, and we start saying behind success of every man, there's a woman. So in these phrases, we gave a woman only a subsidiary role, only an accessory role. Means woman is nothing but a person behind the success of man. Whenever any branch comes, it is father of science, father of biology, father of immunology. Why can't there be mother of biology or father? Motherland, right in the beginning, there were a lot of emphasis on the woman, on the female. But all of a sudden, there come a phase where woman was given a subsidiary role. But I remember when I was a small child, I maybe in the class 5th or 6th, there was a chapter in Hindi book where it mentioned about the Marie Curie. And it was so exciting for me to hear the contribution of a woman. And as she was given the Nobel Prize, that time I learned about the Nobel Prize also, what that is. So there was a phase, there was a dark era, there was a dark phase where the woman was spared from the major challenges in the research, in the country building, in the development. And very soon it was realized, why shall be women deprived of all these things? And then women take the leading role. I'm very happy that the theme of chemical wisdom, first of all, chemical wisdom is fine, but it should not be restricted to the chemical wisdom. If I'm talking about transposons, the greatest discovery, we should remember the Barbara McClintock. The pointer, and the time when there was hardly any facilities, she could change the existing concepts of genetics. And she could come, I can understand the amount of challenge she would have faced, that everything which was fixed, which was taken as unanimity, and she challenged, no, genes cannot be fixed. They have a possibility that they can move from one place to other place, jumping genes. But yes, determination was there, support was there, hard work was there. And then the power of Kali, the wisdom of Saraswati would have ignited in the ladies, and they could prove, yeah, they are. So that was a trust, and that was faith. So I was just looking the resource person, the 4 renowned personalities, and the field they have chosen, right from the basic research to the application. And sometimes we do research, we apply, but sometimes we are not able to write with full impact, so it can be published. So that care has also been taken by the organizers, and this means they really envision what I congratulate Dr. Pratibha to envision the content of the symposium. All congratulations. Here, I want to mention a couple of more things, especially when we talk about the chemical wisdom or chemistry department. If I say 4 professors and there are 2 females over there. So here in the chemistry department, we are marching equally. If I talk about the 2 research lab, 1 is of female. So chemistry department need a loud applause and congratulations. Yes, the females are coming side by side. And why not? Why women should be considered as only a subsidiary role or a supporting role when they have so much of talent? I fully agree what Dr. Praveen is saying. Why the restrictions are there on the females? Why a female cannot study late evenings? If there is a problem of like protection, or then the protection system should be encouraged rather than discouraging the women to work and marching. So we are all excited to hear our respected and resourceful person, the veteran scientist in the field of chemistry. And yes, as Professor Pani was saying, that chemistry is everywhere. All sciences, all humanities, everywhere. So chemistry is universal. And sometimes in the English phrase, we say the chemistry between two persons is very good. So that indicates, yeah, everything is doing very, very good. So chemistry is universal, chemistry is everywhere. Let it be life sciences, let it be physical sciences. And that is connecting link between the biological sciences and physical sciences, the chemistry. So I never say that chemistry is only of physical sciences, when the biological sciences also own the chemistry. So with this, I think I'll conclude my talk here, and my best wishes for this international symposium. An international symposium. Besides this talk, I was looking that there are many poster presentations and quiz competition also. So that's going to be a grand success. My best wishes for a wonderful and a thoughtful day of this international symposium. Thank you.
Oh, thank you so much, sir. So wonderful. You always encourage every one of us. Thank you so much, sir. Before moving on, we would like to share an important information to all our participants that to get a certificate, you need to fill the feedback form. For the link for the feedback form will be shared in the chat box. And you also take part in the quiz, which is going to happen at 3:30 p.m. and get an additional certificate. So stay tuned. Well, we cannot hope to build a better world without improving the individuals. This seems to be the working mantra of our teacher in charge, Professor Devnandan sir. He's always setting up high goals and high standard for each one of us to bring out the best. Sir, please address the gathering. Over to you, sir.
Thank you, Dr. Archana. Am I audible?
Yes, sir, yes.
Okay. So very good morning to one and all. On behalf of Department of Chemistry, Deshbandhu College, I welcome Chief Guest Professor Pani, Honorable Chairman, Governing Body, Sri R.N. Bas, Dr. Praveen from Skill Council of India, all distinguished faculty members, research scholars, students to the international symposium entitled Chemical Wisdom by Her. I would like to thank Professor Rajiv Agrawal, the principal of our college, who is putting his all efforts towards the holistic development of our college and always motivating us to organize such events. I also thank Professor Kamal Gupta, Vice Principal of our college, for giving constructive and useful suggestions for organizing this international symposium. With immense pleasure, I welcome today's speaker, Professor Ila, Dr. Sumati Bhatia, Dr. Khushbu, Professor Shivani. The symposium entitled Chemical Wisdom by Her is designed to bring the research and career interest of women in the field of chemistry. The main aim of the symposium is to illustrate the strength and depth of the contribution of women in chemistry, to raise awareness of the opportunities for capacity and knowledge development for women aspirants in the field of chemistry, and to promote international solidarity and cooperation, to encourage women students to opt chemistry as career and pursue research in this field. The one-day symposium will focus on thematic presentations and discussions featuring prominent role models to address various issues of interest for women working in the field of chemistry, including the particular challenges and opportunities they face. The resource person would share a stories from various perspectives about research and career development and challenges faced and overcome along the way. Deshbandhu College, being one of the best colleges in science, puts various efforts in popularizing subjects like physical science, life science, chemistry, industrial chemistry among students. Many awareness programs generating exposure to the work and life of successful scientists is organized by the college on regular basis. The women professionals share their views with students and their parents and motivate them. College also organizes visits to science laboratories and institutes for the students time to time. Department of Chemistry, Deshbandhu College is working with the aim is to establish an inclusive community with the emphasis on diversity and inclusion. The idea of this international symposium has been thought by Dr. Pratibha, who herself is actively involved in research and other academic works of the college. She is very sincere and hardworking and has high commitment for work. All the faculty members of the chemistry department have put in a lot of sincere efforts to bring up this event, and I believe the participants will learn a lot from this symposium. I congratulate all the faculty members of the department and extend my best wishes for all success of the symposium. In the symposium, we have other activities, including e-poster presentation and quiz to make the event interesting and fun-filled for the students. I hope all participants will be benefited from it. Once again, I wish all the very best for the success of the symposium. Thank you. Over to Dr. Archana.
Thank you, sir. Thank you so much for your inspiring word and giving us platform to explore the potential. Thank you, sir. Thank you. Now we would like to invite heart of our symposium, the chemical wisdom of our department, a true researcher and a dear Dr. Pratibha Kumari, the convener of this show. Please come and say a few words, Dr. Pratibha. Over to you, Dr. Pratibha.
Thank you, Dr. Archana. Am I audible?
Yes, you are.
Okay. Yeah, a very good morning to all. Today's event rightly represents that a wise woman does not keep her wisdom to herself. She shares wisdom with the world. With this theme, I welcome you all on the behalf of Department of Chemistry, Deshbandhu College, to this international symposium on chemical wisdom by her. We are really thankful to our honorable chief guest, Professor Balram Pani sir, Dean of College, University of Delhi, for gracing the occasion and sparing his precious time with us. It is indeed an honor to have with us our distinguished chairman, Shri R.N. Vatt sir, who shared his inspiring views. We are extremely privileged to have Dr. Praveen Dhameja, Advisor, Skill Council for Green Jobs, Government of India, for sharing her words of wisdom and inspiring all the women. She truly represents the tremendous potential of women for being an instrument of societal transformation. Visionary and luminary principal of our Deshbandhu College, Professor Rajiv Agarwal sir, we are very grateful to you for wholeheartedly supporting us in organizing this august gathering. Our sincere thanks to Vice Principal Sir, Professor Kamal Kumar Gupta, and IQAC Coordinator, Dr. Aditya Saxena, for their constant guidance. We are deeply indebted to our teacher in charge, Professor Devnandan Kumar sir, for his consistent efforts and persistent inspiration. And we are very sure that this symposium will be instrumental in motivating the upcoming generation to pursue their career in research and higher education. We firmly believe that this event will be a milestone in unrevealing the greatness in every woman. We are fortunate to have wonderful speakers with scientific wisdom in today's symposium. Our eminent speaker, Professor H. Ila, Honorary Professor at Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore, India, Dr. Khushbu Kushwaha, Managing Editor at Wiley, Dr. Shivani Mishra, Professor at University of South Africa, and Dr. Sumati Bhatia, Professor at Trade University, Germany. They will enlighten the young minds with their scientific acumen. We at Deshbandhu College are also undertaking research activities, being inspired by our female scientific leaders. I'm also involved in research at Bioorganic Material Research Lab, where many students are trained to inculcate research aptitude for addressing these societal issues through the perspective of chemistry. We have been conducting national and international webinars to provide extensive exposure and collaboration opportunity to all faculty members and our students. In this regard, last year, we organized an international lecture series. We were fortunate to have the seasoned scientists across the globe. I'm glad to share that we are planning to organize an international conference in the month of September 2022. We hope to continue with the overwhelming responses and association with you all in near future. We extend our warm welcome to all the speakers of the today's session, all faculty members, research scholars, and all other participants for today's symposium. We hope you all will enjoy this one-day symposium and will have a great learning experience. Thank you so much. Over to you, Dr. Archana.
Thank you. Indeed, your passion is inspiration for many of us and a message to adopt atomic habits and stay positive in all the situation. You are really an inspiration, Dr. Pratibha. The way you work in the department and in the college, it is a great inspiration for all of us. How do you manage so many things? Great. Look like our program is geared up to move up a lecture session. So now I would request Dr. Leena, could you please share the schedule for the day? Yeah, thank you for sharing the schedule. Looks like we already geared up to move on the lecture session. There are going to be two sessions. Session one, there'll be two lectures by the eminent scientists. One by Professor H. Ila from Jawaharlal Nehru Center for Advanced Sciences Research, Bengaluru. Dr. Khushbu Kushwaha, Associate Managing Editor at Wiley. Professor Shivani B. Mishra, that will be in session 2, University of South America. Dr. Sumati Bhatia from Freie University, Berlin, Germany. They all are going to give us a wonderful lecture, so we are going to move towards this session. I will now hand over to Dr. Leena Agarwal, the coordinator of session 1, to take the program forward. Over to you, Dr. Leena.
I think, Dr. Leena, we can play some videos that we have conducted some workshops here at Deshbandhu College in chemistry department. Dr. Leena, we can play some videos here.
Ma'am, I have that college video.
Oh, that's fine. Yeah.
Yeah, that's fine.
Some videos. Yeah.
Yeah, please.
So that will represent some events that we are organizing in our college and the infrastructure that we have. So Dr. Leena, please play the videos. Yeah, thank you so much, Lina.
I think, Pratibha ji, we have another video.
Lina, can you please play? Can you please? Okay. For the timing, she can, Dr. Lina, can you display the program schedule? So just which we are going to
Yes, ma'am.
organize today. Dear participants, so this is the schedule. If somebody has missed, so you can, because it's difficult to circulate to all of you, so you can go through this program. Like we have circulated through emails and through a WhatsApp group, but some of you may not have received the this program schedule, so you can go through this. Like our first session will start at 10:50. We'll start with our first lecture, and we have Professor H. Ila, and she is the honorary professor there. She has served at different places. So she is a very renowned scientist, and she is very dedicated for research. And I will say she's a kind of a inspiration. Like if you search her name and just Google her name, you will come to know like she has devoted her whole life for the science and for the development of science. And it will be a very nice experience to learn about the heterocyclic compounds, because she has developed a coupling reaction also, because we all are from chemistry, so we know the importance of coupling reactions. So she developed a name reaction, that the Ela-Jinjupa coupling reaction. So it will be very nice to learn about this coupling reaction. So this is going to be a very interesting lecture. Now, then we'll have another lecture by Dr. Khushbu Kushwaha. Like whenever we do any kind of research, we have some output, but we cannot keep that output just within up to us or just within in our research lab. This has to be in the science community so that other people can get benefit out of our research. So how to represent our research work in the form of a manuscript, which is very, very important. So Dr. Khushbu will explain all the tips. How can we write a very good manuscript? What are the steps, and what should be aware of, and the ethics for publication? Everything will be covered by Dr. Khushbu. This will be about our first session, the two lectures. Then there will be poster presentation. The poster presentation, there were around 68 posters that we have received, not only from India, but we have received the poster from abroad also. So we have total 68 posters. We have divided these posters in two categories. One is the experimental based poster, another one which were the review based and the theoretical posters. So the evaluation has been done yesterday. So today we will display all the posters that we have received. So that will be at 12:40 p.m. Then we will have a lunch break. Okay, short lunch break, but don't leave during this lunch break. Stay connected. Then we'll start straight away. We'll start the session number 2. There we have two speakers. One is from South Africa, Dr. Shivani Mishra. She will tell about the soul gel technology to prepare nanoparticles or different materials. Okay, nowadays we are making different types of nanomaterials. So there are different techniques for the synthesis of nanomaterials. So she will talk about soul gel technology to prepare materials which are useful not only in the medicinal field, but in other fields. Okay, now we are exploring nanomaterials in almost in every application area. So she will talk about this technology, which is very simple and very effective to prepare very good quality of nanomaterials. So that will be taken care by the Dr. Shivani Mishra. Then we will have last lecture by Sumati Bhatia. Okay, so she will taking a very interesting topic, like nowadays we all are facing this virus related problem. So it's the COVID that we all have seen, and again we are facing this problem. So she will talk about like how polymeric nanomaterials can be used for facing this problem. How can we develop different type of therapeutic agents or the imaging agents, or for and even for the monitoring treatment, how these polymeric nanomaterials can be used. So she will talk about how can we use these materials for for treating any disease which is caused by viruses. So today we'll going to have these 4 very interesting lectures. So please you all attend these lectures, and based on these lectures then we will have a quiz which is going to be very interesting. So the questions will be related to the theme of the symposium and based on the lectures that you will listen today. So there will be a quiz, then we'll start with the valedictory. In valedictory, we'll announce the prize for the poster presentation, for the quiz, and then there will be a vote of thanks at the end. And this is also very important because somebody may be worried about certificate. So you need not to worry about certificates. Certificates will be emailed to you, but the attendance in the conference, in the symposium is important. So you all have to be present here to get the certificate. So for that, you have to fill the feedback form. So this was about the feedback about this symposium schedule. Okay, thank you so much. I think Dr. Leena, now you can take the charge. Dr. Leena.
Yes, ma'am.
I think now we can start the session.
Okay, ma'am. Okay. Good morning, everyone. Myself, Leena Agrawal, Assistant Professor, Department of Chemistry, Deshbandhu College. So let's start with the first session of the symposium. In this session, we will have 2 lectures from Professor H. Ila and Dr. Khushbu Kushwaha. The session will be chaired by 2 of our faculty members from Department of Chemistry, Deshbandhu College, University of Delhi. That is Dr. Namita Gandhi and Professor Sushila Singhal. First, I would request Dr. Namita Gandhi, Associate Professor, Department of Chemistry, Deshbandhu College, University of Delhi, to introduce and invite the first speaker for this session, Professor H. Ila, to the audience. Over to you, Namita ma'am. I think some technical glitch is there, so let's wait once Namita ma'am will join.
Leena, Dr. Leena, please make co-host ma'am ko.
Okay, okay.
Good morning. Thank you, Dr. Leena. We now begin this first session. Am I audible?
Yes, ma'am. Yes.
Okay. Before I introduce the speaker for this session and invite her for a talk, I just want to tell the audience that they can put their questions related to the talk in the chat box. And in the end, Mr. Sanjay Kumar will then collate your questions for the speaker. I am privileged to introduce Professor Hirya Kakkanwar Ila, Honorary Professor, Jawaharlal Nehru Center for Advanced Scientific Research. Professor Ila has a long-standing career. She did her PhD in organic chemistry in 1968, being the first woman PhD from IIT Kanpur. And after 1 year postdoc from USA in 1969, she joined Central Drug Research Institute, Lucknow, as a scientist. And in 1977, she then moved to Northeastern Hill University, Shillong, and established a state-of-art chemistry department there. She was promoted as a professor there and published some of the breakthrough papers in heterocyclic chemistry with her husband, Professor H. Jujanappa, which are highly cited. And they have a name reaction to their credit, Jujanappa Ila Aromatic Heteroatomic Annulation, GI annulation. After serving NEHU for 18 years, she moved to the Department of Chemistry, IIT Kanpur, in 1995 as a professor and continued there till her superannuation in the year 2007. Afterwards, she moved to Bangalore and joined Jawaharlal Nehru Center for Advanced Scientific Research as a Hindustan Liver Research Professor, honorary professor, and still pursuing research there. Her area of research is the design and development of new building blocks and methods for heterocyclic synthesis. She has supervised around 65 PhDs and has nearly 285 research publications in the international journals. She has been Alexander von Humboldt Fellow, Marie Curie Visiting Fellow, and has visited several countries on lecture tours and international symposia. She was elected Fellow of Indian Academy of Science, Bangalore in 1991 and Fellow of Indian National Science Academy, Delhi in 2001. She received the Lifetime Achievement Award of Chemical Research Society of India Gold Medal 2019, and she has been recently awarded A.V. Ramarao Foundation Prize in the year 2001. Ma'am, I invite you for your lecture. After reading this loaded biodata, I'm very happy to welcome you here, ma'am, for your lecture titled Design and Development of Efficient and Sustainable Synthetic Methods
Can you sit for 45 minutes?
Important heterocycles. Welcome, ma'am.
Start. Thank you, Dr. Pratibha Kumari. Can you hear me? Hello?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Thank you, Dr. Pratibha Kumari, for inviting me to give a lecture in your symposium, international symposium. I accepted it because you are Professor Chauhan's student, and Professor Chauhan was the first student of my husband, Professor Junjappa, actually. So the title I have sent, you have introduced me. No, but what is this? This is not coming. Deshbandhu. You just go next. This is different, you know. Which one? You have opened different. Deshbandhu College, you know. This lecture, just 1 minute. Just open it. This one, yeah. Yeah. Maybe not this one. This one. Wait. Yeah. So I start my lecture. I dedicate this lecture to my husband, who recently passed away on 16th November, because we were always working as a team. There is a personal profile which has appeared in Current Science. You can go through it. Okay. Before I come to my lecture, I want to tell you the importance of organic synthesis. Science cannot progress without ability to design and produce new molecules and new materials. So there is no doubt that organic synthesis is one of the most important scientific disciplines, will never become obsolete. Synthetic organic chemistry has impacted the allied sciences. Not only this, biology, medicine, material science, you require the molecules which are synthesized only by organic chemists. I mean, these are the quotes I have taken. Modern life on this planet would be inconceivable without the contribution of organic synthesis. It is difficult to imagine another discipline that has a greater impact on human life than chemistry. Synthetic organic chemistry is the primary driver for creation of all those advances. I leave this one. Okay. Now I come to, if you see there are so many Nobel Prizes which have gone to organic synthesis, peptide synthesis, supramolecular chemistry also you have to synthesize supramolecule, fullerene, conductive molecule also involves organic synthesis, asymmetric catalysis, metathesis, cross-coupling reaction. Only area, biggest discovery which was left out without Nobel Prize is one of the most impactful contribution of organic synthesis to humankind is the discovery or introduction of, pills, contraceptive pills, envoys to control human reproduction. This has, my opinion, single great contribution to humankind. But this was gone without recognition by Nobel Prize. Otherwise, so many, organic synthesis have been recognized by Nobel Prize. And not only this, as I told you, synthetic organic chemistry has impacted other branches, biology, medicine, material sciences. And so especially in medicinal chemistry, where molecules are sought to chemically modify disease state. You make molecules to modify the disease state, whereas in chemical genetics, molecules are used as a probe to study biological system. What I want to emphasize is, organic synthesis plays very important role in drug discovery research. Okay. Now, how do we get these small molecules? The earlier source was natural product. Many like Taxol was first, it was discovered from a plant, yew plant. But the thing is, sometimes quantity is less and isolation is difficult. And then there are commercially available compound collections. People test them also. But the thing is, there is not much diversity in them. So the problem associated with use of natural product and traditional commercial available community libraries in screening experiments have spurred the development of variety of synthetic approach, de novo creation of small molecule collections. Now the question is how to synthesize efficiently large collection of molecules with high level of diversity and complexity. We have to synthesize diverse molecules, drug-like scaffolds. If you just synthesize molecules, they has no meaning. So not only we have to develop technology, but we have to also develop new chemistry, new reactions. That is very important actually. So, Schreiber has given a term diversity-oriented synthesis. A general consensus has emerged that library, it is not the library of molecules should be big. Library should have a diversity. So that is called diversity-oriented synthesis. And you can have diversity in the appendages or subsequents. You can have functional group diversity. You can have stereochemical diversity. You can have diversity in scaffold. I'm emphasizing this because we work on diversity-oriented synthesis. We always introduce diversity in our synthesis. Another thing which is important is complexity generation reaction. How do you generate complexity in short system? Okay. Besides this, there are many technologies now which are used: polymer-assisted solution phase synthesis, microwave assisted organic synthesis, flow chemistry. But despite all this, what is needed is, the most important is, it is the quality of compound library which is important. Means how to bring out new chemistry, original chemistry, to make a new library. Okay. So this I have taken quotation last from Nicolo. What is the objective of synthetic organic chemistry? The objective of synthetic organic chemistry is advancement of their field through discovering and inventing new reaction and designing innovative strategies. We have to discover, invent new reaction, and then search their application. Okay. In the past decades, I will show you so many new kinds of reactions: transition metal catalysis, C bond formation, C hetero bond formation, click chemistry, multi-component reaction, domino reactions, or ring closing metathesis. Many new reactions have emerged actually. And now, what is the future of synthetic organic chemistry? vertically it empowers the synthesis, and horizontally it enables associated field. I will say the vertical direction holy grail is that we should have a ideal 100% yield, zero waste reaction. I'll show you. And also in horizontal direction, it enables other fields like material science. It enables medicinal chemistry, drug discovery, in many areas, supramolecular chemistry actually. Now I come to, my work. Before I come to my work, I've given one synthesis by Kishi. That is some fish. This is a fish toxin, which is synthesized in 100 steps. And yield, you see 1, 2, 3, 6, 7, 8, 0, 2% yield. Okay, this is like climbing Everest. But you cannot use it in the laboratory because if you want this compound to be used as a drug or some biologically active compound, you cannot synthesize it. You will get such a small amount of compound. Okay, so this is the theme. What is ideal synthesis? Nowadays, your method should not be more than 4 or 5 steps. That your strategy, you design a strategy before you start. So strategy should be efficient, innovative. There should be total conversion, no side product form. That is called atom economy reaction. It should be 100% yield, and also using catalytic reagents than stoichiometric reagents, because then you waste less chemical. And most important is reduction of steps. You should not have protection, deprotection. This is called domino reaction, multi-component reaction, means you can perform 3-4 steps in one pot. In multi-component reaction, you can push 3-4 components sequentially or one pot. So you save, evolution of solvent and solvent waste you save, and all. For environmental point of view, these reactions are economic aspect is very important. You have to use cheaper chemicals, environmental readily available recycling starting material. So our chemistry is based on these ones. Okay. My area is heterocyclic chemistry. We synthesize heterocyclic chemistry. The top, is it available for you? Is it visible? Titles. Hello?
Yes, ma'am, it's visible. Yes, ma'am, it's visible.
Okay.
Yes, ma'am.
So if you go through among drugs, most of the drugs have, top 15 drugs have at least one heterocyclic molecule. You see here, isoxazole, quinolone, again quinoline, hydantoin, benzopyridazines. So heterocycles play a very important role, especially in drug discovery and also in material science. Okay. So now I start my work. Our work is based, our approach is that we develop our own new building blocks and then design new reactions around them for generating new heterocycle cores and other things. So earlier we had been working on a class of compound, polarized ketene diethyl, which are easily, in fact, Chauhan is the one who started this work, which are easily available from active methylene compound, carbon disulfide, and then alkylation. We have explored them like such kind of polarized ketene diethyl, nitroketene diethyl, and beta-keto diethyl. So this work has been reviewed in Chemia 2013. It was a chemistry in India, so it was invited review. But today I will be speaking on this class of building blocks which we have designed. The building blocks are new. See, all have sulfur at least. And then how we design new reaction on this. Okay. So I will be covering transition metal catalyzed cross coupling reaction. Atom economy reaction means transition metal catalyzed CH activation, functionalization. This has become very important. Domino reaction means, I told you, multiple bond forming reaction in one step. Sequential multi-component reaction, you can put 2-3 reactants in one pot. Then I will also speak transition metal free cross coupling, and then how you can discover new reactions. Okay. So this I have shown you, transition metal cross coupling reaction. Cross coupling, you require I mean, it is a CS bond form, a CN bond formation from same organosulfur compound. You see there is a bromine. Usually cross coupling takes place either triplet or bromine. And you react when in one part only we react with amine. So we get this inaminonitrile. And then we put copper catalyst in presence of protein ligand. We get amine 3-cyano-2-heteryl indoles. It's a new synthesis. And you know, indole is the king of heterocycles, and indomethacin, so many drugs they have indole scaffold. Okay. So here I have, see, once we make it, we generalize the reaction by taking 15-20 examples. So I have shown you the diversity at 2 position, at n position, and diversity, you can have electron donating, electron withdrawing groups around. Okay. Now the question is, see, if you want zero waste, I mean, every time we have to hang a bromine or iodine to have cross-coupling reaction. So scientists argued, can't we make direct CN bond having H here? I mean, that is called CH activation reactions, you know, and functionalization reactions. Can we make CN bond? This is atom economy reaction, because here bromine is getting wasted. So we have developed a new synthesis of same indoles that is called palladium catalyzed CH activation. I mean, we use cupric acid to oxidize palladium 0, which is evolved. Many of the slides I'm not showing. So here now you see we don't need bromine or iodine, and reaction goes, and we have made a variety of indoles. I mean, having diversity, see, even CO, it is not the alone CN, we can have a benzoyl group here also. So this is again, I have shown you this, library of indoles which we have made by CH activation. Now I come to benzothiophene, intramolecular CS bond formation. Same intermediate, we are making benzothiophene. Benzothiophene are very important. Raloxifene is a, drug by Lilly, selected estrogen receptor. Azoxyphene is a uterine cancer therapy. It is used. This is tubulin polymerization inhibitor. So first we develop simple one pot. We develop one pot cross-coupling reaction. You take this dithioesters, like esters have been explored a lot, but dithioester, it is our group only which has explored. So in presence of base, if you react, you get thiolate ion, put cuprous iodide, you have benzothiophene. So again, we made the library of benzothiophene having different, diversity at various positions. Heterocycle group, SME group, OET group, amino group, and all. Okay. Now again, question comes. See here, we have a halogen here. Can we remove halogen here to make it more atom economy reaction? No waste. This is called CH activation, C heteroatom bond formation. Yes, we can. So we react this thiolate anion is generated. We use it two-way, either thioinol isolate. Again, you use palladium catalyzed CS bond formation. Cupric acetate is used to oxidize PD0 again, and we get good yield of benzothiophene. And again, we made library. You see, not only CN is there, ester group we can introduce, aryl group we can introduce. And so, we generalize the reaction and yields are good. Okay. So using this strategy, we made raloxifene intermediate. This is raloxifene. So we made this intermediate starting from desoxybenzoin using dithioester and then palladium catalyzed CS bond formation and deprotection. Similarly, we made tubulin polymerization inhibitors. They're cytotoxic compounds actually. Okay, and we further extended the reaction to make 2 aminothiophenes, CH activation only. Here, instead of reacting, see, like here, we react with dithioester. Here we react with isothiocyanates. Okay. And we have made 2 anilino aminothiophenes, benzothiophene, using same strategy. Okay. Now I come to other heterocycles. different kind of chemistry. This was cross-coupling reaction, CH activation. Now, See, pyrosols, there are, if you take pyrosol scaffold, some of you must have made also. I mean, they are COX-2 inhibitor, anti-inflammatory compounds, so much they use in Merck and all, kinase inhibitors, so many. I mean, pyrosol heterocyclic is very important. The only thing, the drawback of pyrosol synthesis is usually you make from 1,3-diketone. If you react with phenylhydrazine, there is a problem with regioselectivity. This NH2 can react this carbonyl, or NH2 can react this carbonyl, and we get mixture of regioisomer. So we thought, if we have, instead of 1,3-diketone, we have replaced CO by CS, monothioketones. C double bonds has different electronic character, and easily we can make. You take any active methylene ketone, react in base with dithiester, you have monothioketones. This is all, they were known, but nobody had studied synthetic application. They exist in this hydrogen bonded form. And now we have developed a highly regioselective method for pyrosol synthesis. These 1,3 monothioketones, just you reflux in ethanol. So what happened? NH2 group attacks CS bond, NH phenyl attacks CO, and we get only one regioisomer, in which 1, 2, 3, 5 position there is a 4-chloro group, and 3 position there is a phenyl. On the other hand, if you convert it, treating with methyl iodide, beta methylthioenone, now you, in presence of base, you react with phenylhydrazine. The regioselectivity is reversed. NH2 attacks CO group, NH phenyl attacks SME group, and we get another, exclusively another regioisomer. At 3 position, we have 4-chlorophenyl, 5 position phenyl group. We have proved the structures by X-ray, and we have also docked up one-pot reaction. We need not isolate it. In one pot, monothioketone, you put methyl iodide, put phenylhydrazine. So using these techniques, we can, I mean, this is a highly cited paper. Using this technique, we have made so many regioisomers. I have shown like this paper and all. We have, I mean, pair of pyrosols having different groups at 3-5 positions. Not only this, you can extend this strategy to make isoxazoles. I'll show you later. Isoxazoles are also very important in medicinal chemistry, and you can make regioisomers. See, like if you react with hydroxylamines, if you just react with base, this S-methyl compound, barium hydroxide and hydroxylamine, then this thing, AR1 head group comes at 3 position, and AR2 comes at 5 position. On the other hand, if you take buffer, sodium acetate buffer, AR1 comes at 5 position. So regiochemistry is reversed. Here you see, I mean, 3 position, 3 bromophenyl group, 5 position, 4-methoxy. Here 3 position, 4-methoxy. So we can make, this is a very good method for making regioselective, I mean, pairs of pyrosols, isoxazoles, which was not possible earlier. We improved the structures by X-ray. Okay. Because we have been exploring this monothioketone, so we develop now synthesis of thiophene. Thiophene are also very important. The scaffold, you see, there are many drugs for osteoporosis, antiplatelet agent, antidepressant, and there are also semiconductors, material science, they are important. So we develop a one-pot synthesis of thiophenes. You just react in situ, generate the monothioketone anion, react with activated methylene. These things, acylylation, and in situ undergoes intramolecular aldol condensation to give you thiophene. So again, you see how much diversity we have shown. You at 5 position, you can have benzoyl group, sinyl group, ester group, amide group, so much nitrophenyl, aldehyde and all. And then you can make cyclic compound. This is just, we have shown, you can read it. I mean, just we have shown the diversity. Hundreds of thiophene you can make by this method. Not only this, we also made fluorescent benzothioneins. Fluorescent means if you have electron donating group here, and if you have electron withdrawing group here, if you take bromoprotonate, then what happens? There's a extended conjugation, and they all show, I have not shown fluorescent spectra because of time. I mean push-pull thiophenes, which are highly fluorescent, red, yellow, green in color. So we could also make fluorescent thiophene. You should go through this paper. Okay. Next, we use this monothioate ketone for synthesis of imidazoles. I mean, this is a very nice example of sequential multi-component addiction. First, we standardize it. Room temperature, we can see as glucose and we get this in aminoketone. Put sodium nitrite, we get a beta nitroso compound, and potassium carbonate cyclizes CH2 to give imidazole, tautomers of course, but when we alkylate, we get only one tautomer, 1-methyl 3-benzoyl tautomer. Okay. Then we thought, why not perform everything in one pot? In one pot, we put, of course, this is called sequential multi-component reaction. Put benzylamine, then then you put sodium nitrite. When TLC, you have to check. And when nitroso compound is formed, you put potassium carbonate, and you get this imidazole. So it's a good synthesis. It's not much. Here 87%, here it is 7%. So they are called sequential multi-component reaction. So using this strategy, see, we can introduce, if we take allylamine, we can have a double bond. If we take propargylamine, we can have a triple bond. Orthomethoxybenzylamine, thiophenone CH2 compound, if we have glycine. So you see how much diversity we have. Even we can have, these are very good complexing agent. We can have ortho position OH group. Okay. So this is another application of monothioate ketone. If we take ortho-bromo compounds, this again a benzothiophene synthesis, but new synthesis. One pot we can make 2 bonds, CS bond and CC bond. First you treat with cuprous iodide, and which is iodine is more reactive, CS bond is formed. This intermediate we isolated and magnified, but afterwards we didn't isolate. And directly we put palladium catalyzed intramolecular CC hack coupling with it. This is one pot. Synthesis substitute benzothioanes, we have sequential 1 pot copper and palladium catalyzed CS and CC. CS and CC bond are formed in 1 pot. And you see, you can have so many kinds of electron withdrawing, electron donating substituent in aromatic ring. And then you can have different kind of carbonyl groups. And here amino, alkyl, and this thing. Even we can make such kind of dimer, which is very important in material science. So I have summarized here, because these monothioate ketones were not studied earlier. We can have a regioselective synthesis of pyrazoles, isoxazoles, thiophenes, imidazoles, and benzothioanes. Now, one recent paper I'll show you, isoxazole synthesis. If you go to isoxazole, if I have shown their biological activity, antidepressant, neurotoxin, COX-2 inhibitor, antifungal, and all. And these are the some antibacterial antibiotic which have this isoxazole, right? Okay. So the methods, if you see, most of the methods are isoxazole things are through nitrile oxide and triple bond. What I want to emphasize is NO bond is there. Already predisposed NO bond in these all methods. But we wanted to method where we are making NO bond. So I'll show you how we have generated a new method. See, these monothioate ketones, we wanted to react with sodium nitrite to make triazole. We didn't get triazole. When we reacted with sodium nitrite in presence of ABX, we got isoxazole. And I'll show you the mechanism how they are formed by NO bond. This is generalization of reaction. You see 1,3,5 position, we have so much diversity we have developed. Not only this, we made oxazoline antibacterials, this thing this scaffold, isoxazole scaffold also, which is otherwise made. We can also have a styrene double bond or dinyl double bonds. Here is the mechanism. Azide group replaces this sulfur bonded IBX, and we get this, and then this thing, oxygen attacks this nitrogen intermediate, nitrogen goes. So what I want to emphasize is this is the new synthesis isoxazole where NO bond is formed. Okay. Now I come to thiazole. Thiazoles also, very important. There are so many drugs having thiazole, this thing. And we synthesize thiazole. See, these dithiazesters have not been explored. So Thorpe-Ziegler reaction is known. So we generate this thiolate anion by reacting this cyanamide then this thing we react with activated methylene halides, and we get 2-position aryl heteryl. So we made a library of these are the activated methylene halides we take. And then these are the dithiesters we take, and see, we generated this library of thiazoles having diversity, not at 4 position, at 5 position and 2 position. Okay. Not only this, we made important these 2 tubulin polymerization inhibitors in one step. Just take dithiester and you get very good yield of this very potent tubulin polymerization inhibitor, which have been made in the literature by long method and low yield. Okay. These are our earlier work. We have also, I will not spend much time on this kind of building blocks we have developed. And we have developed oxazole synthesis, thiazole synthesis, and imidazole synthesis. I will not cover this. This also I will leave. It's a recent paper. I come now, because I have another 5-10 minutes. I come now to, see, I have shown you transition metal catalyzation reaction. Nowadays, transition metals are toxic and costly. So many groups are working. This is a very recent work. They are working to develop transition metal free coupling reactions. So there is one Studer's group. These are the reviews. If you use potassium tertiary oxide in TMDA, you can CC bond formation you can make. See, this is intermolecular CC bond. This is intramolecular CC bond formation. And ligands used are TMDA or phenylthreonine. Okay. So here is the mechanism. They are called as homolytic base catalyzed homoaromatic substitution. This one, gives one electron. There is one electron is injected, so a radical anion is formed. It uses iodide, and phenyl radical is formed. It reacts with another phenyl to give you this biphenyl radical, and potassium tetrabutanoxide takes up a proton. So this takes up a proton. So biphenyl is taken out, and then this radical anion is formed, and this cycle goes on. Okay. Similarly, Kastenbaum has developed this transition, like I have shown you transition metal catalyzed CN bond formation, CS bond formation. So Kastenbaum has developed many heterocyclic synthesis without using transition metal catalyst. Okay. We have also started working, and we thought, if we react with isothiocyanate with orthoposition iodine with active methylene compound, we'll get this anion. So either we can use copper to cyclize it or just as such. So to our surprise, okay, copper was expected 90% yield. We did not put copper in NASDMS room temperature, 90%, 91% yield. Recently we published in Organic Ethers. This is a really very interesting reaction. Otherwise, cross-coupling, we heat at 110 degree, putting palladium or putting copper. Here, nothing. Just put sodium, generate the anion, which adds here. It undergoes cyclization, and we get the product. So we made again the library of various thiazoles, which I had shown, benzothiazoles. Okay. And here is the mechanism. This thiolate anion is formed, which gives one electron to benzene ring to give radical anion. It loses iodide anion to give diradical, which combines. Another reaction. See, I have shown you so many benzothiazine synthesis through copper catalyzed cross coupling, palladium catalyzed CH bond formation, isothiocyanate reaction from 1,3-monothioketone, so many. But the most novel is without transition metal. Just you take same starting material with iodo group here, dithiester, sodium iodide, this thing, you get this anion, and just room temperature within 3-6 power, very high yields. We get benzothiophene, no copper catalyst, no palladium catalyst, nothing is required actually. And we have made so many library of benzothiophene. This also has come in Organic Letters recently only. And not only this, instead of benzene ring, we can have a heterocyclic ring. So these are indolofuse thiophene we can make, thionothiophene we can make, pyrazolothiopene also we can make. So here is the mechanism. I will skip the mechanism. If you want, you can go through the mechanism. Okay. Now I come to domino reactions. I have taken a few examples. This is one of the very good examples of domino reaction where two cyclopentane rings are formed in one pot. If you take such kind of sulfur intermediate, react with some electrophile BF3 this thing, then this cation is formed, which is trapped by this double bond. One cyclopentane ring is formed, and the second carbocation is trapped by two position of indole. Second cyclopentane ring is formed, and also dithiomethylation takes place. Is it not interesting? From simple compound, you are getting such a complex reaction. So this is another domino reaction where ring expression takes place. I will not go in detail. I mean, just one example I'll explain. We also do isocyanate chemistry. If you take this tosyl isocyanate, react it, you see this is undergoing ring enlargement and a pyrrole annihilation. I mean, complexity increasing reaction. So, I mean, I have many systems we have done. I mean, best thing is because all is published work, you can say, so ring enlargement, pyrrole annihilation. Here also, ring enlargement, pyrrole annihilation. Here also 5-membered ring goes to 6-membered and pyrrole annihilation. Here 7-membered rings, 8-membered rings are not easy to make. They can be made. Here is the mechanism. I'm not going, if you want, you can go through the paper. Okay. This is how we generate scaffold diversity. Means we can generate from same reaction. This again we use dithiesters and use simple aryl nitrile or acetates and react with the activated methylene chloride. These 3 amino hydroxy thiophenes are formed. And within, I will show you, within either 1 pot, 2 pot, we can generate the thionofuse heterocycles. So this is 2-step. We get this amino, you copper catalyze reaction, and you have thionofuse indole. This is thionofuse furan. We can generate, but this is a very interesting reaction. You just start with these simple compounds, add bromoprotonate, and ultimately you see from this simple compound we get in one. This is your thienopindole. They are highly fluorescent compounds. So these are 4 bonds and 2 rings are formed in one pot cyclation. They are very good examples of domino reaction. Here also, if you take benzoate with 2-chrombenzoate, you can make isoquinoline. 4 bonds and 2 rings are formed in one pot reaction. And this is, we have done coumarine, thionofuse coumarine. I mean, so many, I will just show you instead of, it's a very detailed paper. I'll show you from simple compounds, acetonitrile, acetate, dithiester, and then this activated bromine functionalized compounds. 10 scaffolds we have generated. 5 oxygen heterocycles thionofused and 5 nitrogen heterocycle choose. You should read this paper. This is called scaffold diversity. From simple chemicals, we are generating a various 10 kinds of scaffolds. Okay, I come to last part now. I'm finishing by 10:35. This is different kind of work. You know, those, I don't know if you read alkaloid, this beta carboline, this is called beta carboline unit. They are very important. They are called tetrahydrobeta carboline subunit. It is a recurring subunit in biologically important indole compounds. Many alkaloids are having. It is a template for drug discovery. I mean, I'm spending more time because this is a very important scaffold, and they show many kinds of biological activity, serotonin receptor, and many alkaloids like harmicine. I mean, naturally occurring, I mean, biologically active, and I mean, compound alkaloids, which show various this thing. They have this beta, this is called beta indole fused with this pyridine ring. That is called beta carbon ring. Okay. See, here also I have shown some more alkaloids having beta carbonyl ring. having biological activity. So what was our purpose? Our purpose was, again, we come back to our polarized ketene diethyl chemistry. I mean, if we react this, we get N-acetyl, we can cyclize them in TFA to make a new class of, they're called enaminones. If NH double bond CO is there, called enaminones. Otherwise, they are called enamino-nitride. So they have a nucleophilic center here, and nucleophilic beta position is nucleophilic. So we thought if we react with this electrophiles, we can annulate 5-6 member ring and make, I mean, this is called acyl annulation. We need not make exactly naturally occurring alkaloids, but bio-inspired, I mean, synthetic alkaloids. So that's what we did. We made these 10-12 enaminones, oxalyl chloride we react, we can annulate a pyrrole ring, either stepwise or in one pot. Or so we can, if we take malic anhydride, we get a CH2COH side chain. They're called indolizidine alkaloids. Okay. And Ninetsky reaction, when you read indole chemistry, you must have read. Ninetsky reaction is done on simple and enamino esters, but nobody has tried on such kind of beta carbon. When we react it, we get a pentacyclic artificial synthetic alkaloid. I mean, it's a big name it has, you can read it, and good, I mean, various yields. And I have shown you the mechanism also. And this is part of many of the naturally occurring alkaloids also. It is not necessary that you have to use naturally occurring alkaloids. Sometimes synthetic compounds are more active than naturally occurring alkaloids. And now we can also annulate 6-member ring. If you take bromopropanyl chloride, they're called indoloquinolizidines. If you use, they're called itaconic anhydride, we can have a quinolizidine with the CH2COH side chain. So we have shown various diversity here, and there are also parts of many indoloquinolizidine ring is part of many naturally occurring alkaloids. And not only this, we have generated this ring system is not non-pentacyclic. If you just do nucleophilic substitution and this chloro, you get this pentacyclic ring. If you do annulation with formaldehyde and amines, you get pyrimidine ring annulation. So by taking simple enaminones, reacting them with oxalyl chloride, itaconic anhydride, malic anhydride, bromopropanyl chloride, Ninetsky reaction, we have generated so many new scaffold. I mean, this is also an example of scaffold diversity generation. We can generate scaffold. I think this is the last slide. So now the time is, I have finished exactly in 10:35. I'm most grateful to Professor Sena Rao. You know, when I joined IIT Kanpur in '64, I was in the first batch. He was the one who took me because I was a biology student. So he took me, and always we were meeting, and I have imagine 58 years association with him now, and he's now 87-year-old, still doing research. And not only this, after my superannuation, when we settled down in Bangalore, I approached him that I need some position. I mean, he had so much confidence in me. He gave me a position, Hindustan Liver Research Professor. This is not honorary professorship, but it is a chair professorship also. And then a small lab, 4-5 students, he gave PhD students, and I still have a few PhD students. I'm extremely thankful to you. And then, of course, my late husband who passed away. In fact, I am not in a mood to give lecture, but I agreed. And we kept a joint team. We always worked together. Junjappa aromatic annulation, which name reaction, not recent organic chemistry, anyone is having. So we worked always together. And these are the students. The work which I have spoken, this is all done in last 12 years in Jawaharlal Nehru Center for Advanced Scientific Research. He is in US, Rockefeller University. He has joined Syngin. Anand is also in Germany. He has joined GVK Bio. I mean, all are in companies And these are the PhD students, 3 who will be recently submitting, and we were the postdoc. So this is the place I always show you. This is the IT Kanpur library. I was there 64 to 68, then 1995 to 2007 as professor, here as a first batch of PhD student. That library came before us. There is a fountain. We used to take tea here. So I'm still very much attached to IIT Kanpur. I mean, many people, those who have worked in IIT Kanpur, they owe a lot to chemistry department especially. And this is Jawaharlal Nehru Center. This is my last resort. When you entered, you will see this. I too have worshipped the shine of science. And this is the path, I say unending path of knowledge I see from my window. Thank you so much. I'll be happy to answer questions. How to open it now?
Yeah, thank you so much, ma'am. It was really very interesting and informative talk. And thank you so much, ma'am, for accepting the invitation. I know you have passed through a very bad situation, but still you accepted the invitation and presented your all work. So you have inspired we all women to do more research in life. Thank you so much, ma'am. And there are few questions there's one question from a student, Palak. She is asking, what are few commonly used coupling agents in polymer composite?
No, we don't make polymers. We don't work in polymers.
I think she is,
we do heterocyclic chemistry. Mostly palladium is used, copper is used. Now they have started using nickel and cobalt, actually.
Ma'am, I have a question this CH chemistry is very important, CH activation.
Yes.
Now, it's a very hot topic nowadays.
Yeah.
And mostly, you have explained, copper salt and palladium salts are used for the CH activation. So what property of these transition metals are responsible for the activity? Like if you want to design something new.
See, actually palladium is the catalyst.
Yeah.
Copper is oxidant. Palladium insert in CH bond. And so that then nucleophile attacks to it. But role of copper, you see one equivalent we are taking. Whereas palladium we are taking 10 more %. Role of copper is because PD0 which is generated to oxidize it to PD2 actually.
So other than palladium, can we use any other metal, or what's the property which is really important for CH?
Usually transition metals are used, ruthenium, rhodium and all. Means now people are diversifying. Many metals are used for CH activation.
Okay. There is one question from the student. Is there any relation between hydrophilic and hydrophobic properties and radical coupling process?
Hydrophilic properties
and radical coupling?
No, nothing. It depends on solvents. You take the proper solvent. I mean, radical coupling. I mean, if your compound is hydrophobic, you have to take some non-water solvent. If it is hydrophilic, take water solvent. Both cases you can do radical coupling.
Okay, I'll take just one question from Dr. Maku. He is asking, what is one particular work of yours that you are proud of, and I can say this, that you are proud of and very close to you?
No, I didn't follow the question.
Dr. Maku is asking, what is one particular work of yours that you are very proud of?
Work, you mean? Work or?
Your work means which work you feel that's the most important work?
I will say overall work. See,
your all work.
See, the research, when you select a research problem, it should not be end of 1 or 2 papers. It should explore the area. We are identified by this polarized ketene diethyl we started. Not only we started, so many groups in China, even India, they have started because they are easily available start building blocks from active methylene compounds are hundreds of compounds, and just you can generate so many this thing. So means overall, I mean, we are identified by area. That is very important. And then we have a name reaction. you can make. Otherwise, I will tell you what is aromatic heteroaromatic annihilation. See, usually aromatic ring, you do electrophilic substitution and you put benzene, you put substituents. But we make aromatic annihilation, we do take a 3-carbon fragment, 2 3-carbon fragment, where already substituents are predisposed, and we join them and generate a aromatic ring. So it is a new approach actually.
Yeah, thank you so much, ma'am. Many faculty members and students are saying they are like very
In
liking
fact,
your lectures.
I didn't show you the photograph that you were telling the proud moment.
Yeah.
Because that DST is bringing, SERB is bringing some book on Vigyana Vidushi. So I'm preparing, that biography. So they said,
Okay.
I forgot to show the proudest moment. In 2011, European Journal of Organic Chemistry has brought issue, and on when Madame Curie's 100 years of Nobel Prize, and they selected 60 women from the world to give an article. And cover page is very nice. There are 60 women, and I'm just next to Madame Curie. First set.
Oh.
I wish I would have shown you that picture. I'm
Yeah.
very proud of that. Also, I'm very proud of my students. They are very well placed. They have worked hard. I mean, you cannot do research without commitment of your students. It's like a family. They are spread out all over world, good, bad, all. They're part of like children and all. I mean, they stay 5-6 years in your group. So means I'm very proud of my 65 PhDs from my research group. So both together, my husband. So it's like in all states, not only like you ask from Mizoram, Nagaland to Kerala, even Tamil Nadu, Maharashtra, Rajasthan, every state we have trained students.
Thank you so much, ma'am. You are really such an inspiration. Yeah. And now I would like to invite Dr. Namita Gandhi to present the e-memento and certificate of appreciation as a token of thanks to Ila ma'am.
Thank you, Dr. Pratibha. Yeah, thank you, Dr. Pratibha. I extend my hearty vote of thanks to Professor H. Ila for this informative talk and very elaborately explaining the intricacies of many synthetic reactions in a simple and interesting manner, I can say, and answering the questions of the audience also. Our students are really fortunate, ma'am, to listen to a scientist of your stature. On the behalf of the department, I now very humbly present the e-memento and a certificate of appreciation to you, ma'am.
What is this e-memento? I don't know.
Yeah, she's sharing the screen, ma'am.
Shall I get it by mail?
Yes, ma'am, sure. Yes,
yes,
I will send you.
We'll be
Send me by post this one.
Yeah. Yeah, ma'am, definitely. We'll be sending you, mailing you both the e-memento and a certificate of appreciation, ma'am, to you.
Okay. Thank you so
Thank
much.
you so much. Thank you so much.
Okay.
And now over to you, Dr. Leena, please.
Okay. Chalo, khatam ho gaya. Thank you.
I would
also working. Yes.
Thank you, Ila ma'am, for such a wonderful talk on design and development of efficient and sustainable synthetic methods for biologically important heterocycles. I would also like to thank Namita ma'am for chairing the session and Pratibha ma'am for taking up the question and answer session. Now I would like to request Professor Sushila Singhal, Professor, Department of Chemistry, Deshbandhu College, University of Delhi, to introduce and invite our second speaker for this session, Dr. Khushbu Kushwaha, to the audience. Over to you, Sushila ma'am.
Thank you, Dr. Leena. Am I audible?
Yes,
ma'am.
ma'am. Yes,
You are
ma'am.
audible.
Yes, ma'am.
A very good morning to all of you. It's my pleasure to introduce Dr. Khushbu Kushwaha, Associate Managing Editor, Belay, India. Dr. Khushbu has obtained her PhD in medicinal chemistry from University of Delhi, India in 2012. The topic of her research was synthesis of azaphenothiazine derived pharmacophores and their anti-cancer activity. She then relocated to Belgium and joined the organic synthesis group at University of Antwerp, UA, as postdoctoral research associate. At UA, her work mainly focused on developing alternative and convenient methodologies for the synthesis of small and medium-sized nitrogen petrocycles. Further, she spent 2 years at Department of Chemistry and Molecular Biology of GU as a visiting researcher and worked on developing liquid chromophores. Overall, she published 20 research papers in high-impact journals, including Advanced Sciences, Science Advances, Advanced Synthesis and Catalysis, EJOC, the Journal of Physical Chemistry C, RCS Advances, BMCL, Physical Chemistry, Chemical Physics, etc. She then joined Chemistry Select Team of Wiley, VCH, in August 2019 as an associate editor and based in Delhi, India. In 2021, she joined the team of European Journal of Organic Chemistry as an associate editor and the Chemical Record Journal as associate managing editor. She represents the whole portfolio of Chemistry Europe and ACES journals as an acquisition editor at conferences and workshops. Great, ma'am. You are such an eminent personality. It's my pleasure to invite you, ma'am. Today's your topic of your lecture is how to write a great manuscript. Welcome you, ma'am. Over to you, ma'am. Dr. Khushbu, ma'am.
Thank you so much, Professor Sushila Singhal, for such a nice introduction. And I hope that you can hear me.
Yeah.
And then I will share my slides. One second. Where do I get the option to share the slide?
You are not able to share? You will find the option. You will find the option. Like check. There is the option share screen.
Yeah, share screen is fine, but after that, it is basic, advanced, and files.
Ma'am, you can go. Ma'am, you can go to share screen. Then you can go in advanced. Then in the advanced, the first is there na presentation.
Okay.
In that you can select the folder where your presentation is.
Okay.
Then in that screen only you will get the option for changing the slides.
So I hope you can.
Yes, ma'am. Yeah. We can see your screen. Yeah.
Okay. And is it moving? Okay, 1 second. I think it is loading.
Ma'am, I think on this screen, numbers will be coming one.
Yes.
Yeah, it's moving now, ma'am. Yeah.
Okay. Thank you so much. Yes, so I'm thankful to Professor Sushila for such a kind introduction, and I'm also thankful to Professor Pratibha Kumari for inviting me to deliver this lecture. It's a great pleasure to be delivering this lecture in University of Delhi, as I did all my education from Delhi University only. So I will just talk a bit about my journey from academia to industry. So I've already been introduced, so I will not go into details. But the most interesting part of my journey is the transition from academic life to industry life. So I would say that as a PhD student, we develop many skills, and we do not realize that how many skills actually we have developed. So like project management skills, writing skills, editing skills, and managerial skills as we guide young students. So there are so many options that we can look for and we should try for. So after my postdoc at University of Gothenburg, where I worked on several interesting projects, so I was very interested to look for other options and to join an industry. And then I found this position as associate editor at Chemistry Select in 2019. And as an editor, my job is to manage the peer review process. So you submit your manuscript as an author, and then as an editor, I read your submission, I go through your manuscript, and then we decide if the manuscript should be sent out for peer review, or then the whole process we manage it at our journals. So I'm a professional editor at Wiley VCH. In 2020, I joined European Journal of Organic Chemistry, Asian Journal of Organic Chemistry, and Chemistry and Asian Journal. And also I'm working as Associate Managing Editor for the Chemical Record. So in this presentation, I will just give you a short introduction about Wiley journals, and how we are promoting women scientists. And in the second part, I will talk about how to write a good manuscript. So a short introduction to Wiley. Wiley was founded in 1807 by John Wiley and Sons. So it is a 200-year-old company. And the interesting fact is that today the 7th generation of the Wiley family is very much involved in the business and taking care of the publishing house. The headquarters of the company is in Hoboken, US. We have 15 million researchers and professionals as our customers. Then we have 5,000 employees worldwide. And we do partnership with universities and launched 222 online programs. And more than 450 Nobel laureates have published with us. We have 70 offices in 28 different countries. And the research team, where I'm also based, is in Noida, in India. If I talk about Wiley Online Library, which is the electronic platform, then we have more than 1,600 journals, more than 21,000 books. We have 200 plus reference works, laboratory protocols, and databases, and nearly 18 million people visit each month Wiley Online Library. So Wiley is also a founding publisher of Research for Life, providing free or low cost access to more than 1,200 Wiley journals in 90 developing countries. So these are our top 5 journals. Angwante Shimi International Edition. This is a top journal. Then we have Advanced Materials, followed by Chemistry, a European journal, which is a broad scope journal. Then followed by Cancer. And at the 5th position is Advanced Functional Materials. So Wiley has partnered with more than 800 societies. So we are a society publisher. So today I'm going to talk about 2 main societies with which I am associated with. So Chemistry Europe is the one society, which is a collaboration of 16 continental European chemical societies. So the individual chemical societies like German Chemical Society, GDCH, Swiss Chemical Society, Societia Chimica Italiana, so the chemical society from Italy. So they all come together and form this collaboration of 16 European chemical societies. And together with Wiley, we publish around 16 journals of high impact, high repute. So these journals are European Journal of Organic Chemistry, European Journal of Inorganic Chemistry. Then we have Chemistry European Journal. We have Open Access Journal, Chemistry Open, and a new journal is launched recently, which is Chemistry Methods, where we publish the methods, synthetic methods related to organic synthesis and all kind of synthesis. Then we have specialized journals which publish in specified areas such as Chem CAD-Chem, Chem Electrochem, Chem Biochem, Chem Photochem, Chem Phys-Chem, Chem Med-Chem. We have Chemistry Select, which is a broad scope journal. So these are some of the journals which we publish together with the Chemistry Europe Society. So moving on. The next society is Asian Chemical Editorial Society. ACES. So like Chemistry Europe Society, then we established the ACES Society, which is a collaboration of 12 continental Asian chemical societies. So CRSI, which is Chemical Research Society of India, is a part of ACES. And together with ACES, we published 3 journals: Chem Nanomet, Asian Journal of Organic Chemistry, and Chemistry and Asian Journal. So if you publish in any of these journals, then CRSI receives a royalty from Wiley, which they can spend for organizing the conferences or organizing any other research related activities. So now I will talk about how we are promoting women in chemistry. So this is a very important area on which Wiley has focused. And since 2019, we are organizing the IUPAC Women Global Breakfast Conference. So where today, this time the topic is Empowering Diversity in Science and African Perspective. And we have very excellent speakers for this Global Breakfast Conference, Professor Cynthia Ibeto, Dr. Lydia Rahman, Dr. Martins Odirendi. Then we also do some special issues dedicated to women scientists. So for example, in 2019, we did a special issue for women in chemistry in Engwanti Shimi. Then currently a special issue is going on in Chem Nanomet, which is for Asian women in materials chemistry and nanoscience. And also a special issue is currently going on in Chemistry and Asian Journal. So we have done many special issues. These are just some examples. And we keep on doing special issues dedicated to women scientists to uplift the women and also to give them opportunity to publish in high impact journals. Then there are various women in chemistry as our editorial board members. So here you can see some examples. Professor M.D. Milton, who is a faculty in Department of Chemistry, University of Delhi. So she recently joined Chemistry Select editorial board. And then we have Sanchita Sen, we have Lee Ju Wu, who is the editorial board member for Engwanti Shimi. We have Bantule Makubela. She is from University of Johannesburg and she joined European Journal of Inorganic Chemistry. We have Tatiana Besset. She is a very excellent researcher and she has joined European Journal of Organic Chemistry. So again, these are some examples, but we have many more women in our editorial board. In our editorial board as well as in our early career research board. So what is the problem associated with these kind of initiatives? So there are some problems. For example, is the lack of women in chemistry leading to them being over demand? So sometimes we feel that women scientists who are in higher sciences and who are like professors in the leading research institutes, they are overburdened because they are invited to be in editorial advisory board members or early career advisory board members of many journals. So are we overburdening them? Then they are also invited as speakers at conferences and they are also invited as peer reviewers. Then the next question is how to encourage more women in science. So in academia, the job prospects are not certain. So there are many short-term contracts, like postdoc is also a short-term contract. Then we have SRF, JRF positions, women scientist positions, but these are not permanent jobs. These are short-term contractual jobs. So are women more pragmatic and choose a profession with more job security? This is also a question. Then different cultures are also a factor. Culture in European countries is different. Culture in India is different. So these are some of the things, some of the questions that we need to find an answer. Okay, so now I will move to the second part of my presentation, which is about manuscript writing. So how to write a good manuscript. But before that, why it is so important to publish? Why we need to publish at all? So first of all, it is our responsibility because many times the research is funded by the taxpayers' money. So it is our responsibility to let them know where their money is being spent. Also, the scientific progress means a lot to the society. Scientific progress impacts their lives. So it is important that we publish the research that we have done and also for the future generation. So they will also come to know about research and what is the progress in the science by means of publications only. Then fame. So if you publish in a high impact journal, then you get recognition by your peers, you get appraisals, you get praise from your peers, and that establish you as a very good researcher, excellent researcher in your field. Then fortune. So the criteria for grant applications, for promotions, and for research funding, sometimes it is the publications. In fact, most of the time it is the publications. So it is important that you publish for the promotion of your in your career, for the grant and for the research fundings. So what is the role of the publisher and journal? So role of the journal is that registration. First is a registration, so which records authors' precedence and merit. So who published what first. So this is very important to know. So it leads to registration and it leads to a record. Then second is editorial and author services. So editorial and author services are very important as we provide the criteria for selection. Peer review process is involved, which oversees the quality control, and it provides the idea for the improvement of the paper. So then we also provide the template. Then we also provide online submission, indexing and abstracting services. So all this is provided by the editorial and author services. So by the journal, by the publisher. Then marketing and discoverability. So it is also very important to share your result so that the work you have published, then it should be cited, it should be read by people. So it is important to share it. So we promote your articles on social media using Twitter, Facebook. Then archiving means that we always make sure, publisher always make sure that your article, the version of record of your article is always available. Then we are also involved in digitalization of the papers which were published in the pre-internet era. So we try to digitalize the papers which were published before. Then the community outreach activities. So we do take participation in workshops, in conferences, such as I'm doing this symposium, and then development of new technologies to assist the researchers. For example, we have Wiley Reviewer Academy, so where you can go and you can do that course to become a reviewer. So writing a manuscript, there are 4 topics that I would cover. What to think about before you start writing, what to think about when you are writing, how to write a good manuscript, the different parts of a summation. So what to think about before you writing? So it is important to create an outline of your paper. So the 4 important questions that should come to your mind when you are going to write a paper is, why did I do this work? So what is the topic? Why the topic is important? Why you have chosen that topic? And how did I do it? So what you have done? What did I find? So what are the results? And what does it mean? So the discussion. So what does it mean for the field? So these are the 4 questions which should come to your mind, and then you should try to create an outline of your paper. So what is an outline? Outline is basically a written plan of the organization of a paper. So you write all the different components of the paper and then you start writing. The outline itself contains little text. Do not think chronologically, but in order of importance. And all co-authors should agree on the outline before starting to write the paper. So it is not important that you first start with title, then abstract, then introduction. It is not necessary. First, you can start either with introduction, you can start with method section, you can start with experimental section first, and then you can work backward and start writing the paper. So it is about the importance, and it is about how you feel comfortable in writing a paper. So it is not necessary that you follow a particular procedure, but you can, for example, you can do, when I was a PhD student, I used to write papers. First, I used to write experimental section. So as I used to do experiments in the lab, I used to write them continuously. So this was my procedure. So similarly, you can adopt any procedure. And the important thing is to create an outline. So it gives you some idea. Then what should you be thinking about when writing. So when you are writing the paper, what you need to think. So first of all, you should have a clearly stated purpose. So what is the aim of your studies? Why you have chosen this particular research area? Why this topic? And then the significant scientific advances. So what are the results and what progress you have made in this particular area? Then sufficiently supported hypothesis. So your assumptions, they should be scientifically proven, and you should give the sufficient proof, sufficient evidence to support your results, to support your hypothesis. So by means of data, by means of citations, by means of experiments. Then you should present logical arguments in the paper. Then what should you avoid? So you should avoid ignoring other inconsistent results. So this is very important. So for example, if you're doing a coupling reaction and it is working with, say, all the electron withdrawing groups, chloro, bromo, cyano, but somehow the reaction didn't work with nitro. So it is an inconsistent result, but you should include it. It is very important. So even if you do not know the reason, and sometimes we do not know the reason for a particular phenomenon or whatever is happening, but it doesn't mean that you ignore that result. So please include that. Then exaggerate the significance of your result. So do not exaggerate, basically. Sometimes we made some claims which are not proven in our paper, and that leads to rejection of the paper. So do not exaggerate the significance. Then do not use too much jargon, too many abbreviations. So one time an author was using nano word too much in the manuscript. So in the abstract, in the title, it was nano, when the nanochemistry was a very hot topic. And it is still a hot topic. So one of the reviewer commented that this is the paper with nano novelty. So do not include so many jargons again and again in the paper. Then repeating bits of data and text. So do not repeat the data and text. If you have compiled something as in the table or as the figure, then do not need to write it in the text. Then behaving unethically. This is the very important point. So do not behave unethically. What does it mean? So there are some things which we consider ethical misconducts. So for example, author misassignment. So sometimes we have seen that someone who should not be on the paper is included in the paper, which is totally unethical. Or sometimes someone who should be in the paper is not included. So both of these things are unethical. So ghost authorship, gift authorship is inappropriate and is considered as unethical. Then duplicate summation or publication. So do not try to publish a previously published paper in another journal. So this is totally unethical. Inadequate citing. So you need to give credit to the person who has done the previous studies or on which your work is based. So inadequate citing is unethical and should be avoided. Because we also have the data to check the similar studies, and we know that if there is some similar study and you have tried to ignore the paper. Then plagiarism or self-plagiarism, this is very important. So there are two kinds of plagiarism. One is intentional plagiarism, so where the authors deliberately try to copy someone else's idea, someone's work. So this will be considered as intentional plagiarism. Then we have unintentional plagiarism, so which is also considered as self-plagiarism. So where an author extensively citing, extensively reviewing the previous papers, end up using too much of the original text. So that will be considered as self-plagiarism, which is again not ethical, and which is again the paper will be rejected, or we will ask authors to rewrite. So please avoid plagiarism. Then fraud, data falsification. So making up data, using computational data as a real experimental data. So these are considered as data falsification. One time we have an author who presented an NMR spectra, which was not real. And it was consist of same peaks which were repeating again and again. So we could find it out, and we have the image manipulation checks, and we can get to know about these things. So please do not involve in data falsification, and then image manipulation is also not allowed. Then what is a good manuscript? So what is a good manuscript? A good manuscript is the one where the message of your where the message is very clear and easily understandable. So that we will consider it as a good manuscript. So here I'm giving you a very simple example. So there is a guy on the left hand side and who is thinking about a particular blue car. Now there is a guy on the right hand side, his friend, and he's not able to understand which particular blue car. And what are the details which this guy is giving to his friend is that my car has 4 wheels, my car has blue color. Now all the cars have 4 wheels, and there are so many kinds of blue car. It could be a Nissan car, it could be a toy car, it could be a Tata car. So it is very difficult for his friend to understand which particular car he is talking about. So this happens like when you are writing an article, you know about your work very well, and you have all the things in your mind, but you are not able to communicate well. You are not able to tell the audience what is the importance of your work, or what are you trying to say, and what is the scientific advances in this work. So these are some of the things that you need to be careful. So what is a good manuscript? Where the readers can grasp the scientific significance easily, which has a clear, useful, and exciting message, which is presented and constructed in a logical manner. So then we consider this as a good manuscript, where there is a significance, where there is a scientific significance that the readers or audience can grasp easily, which has a useful and exciting message, and which is constructed logically. So what are the different parts of a summation and how an editor reads a summation? So when you submit your manuscript to the editorial office, the editor will go through your summation. So these are the different parts, and each section of a paper has a definite purpose. So title, abstract, keywords. So this is very important that you include a lot of keywords in the title and abstract, and keywords should be chosen carefully. Because this make them easy for indexing and searching. So they should be informative, attractive, and effective. Then you have the main text. Main text consists of introduction, methods, results, and discussions. Then you have the conclusion, acknowledgement, references, and supporting materials. So I will go through these different components one by one. So first is the title. Okay, before that, I would just like to tell you that you submit a manuscript to the editorial office, but it is not possible that all the manuscripts will go through the peer review process. Why? Because we have an initial screening. So we check your manuscript before sending it out to a reviewer. So what an editor look for in your manuscript before sending it out to a peer reviewer? So we check if the manuscript fit with journal's scope and aim. So manuscript, so you should choose a journal very carefully. So first you should go through the journal's aim and scope. You should look at what this journal publishes. So for example, if a journal just publishes review articles and you have submitted a research article, so this is very obvious that your paper will be rejected. Now, second example, if, for example, you have done the research and you have done some synthetic part and some medicinal properties, anti-cancer or antimicrobial. Now, the focus of your manuscript is on medicinal part more and not so much on synthetic part. Synthetic part is previously published, is previously known, for example. So in that case, your manuscript will not fit a journal which is dedicated to organic chemistry. For example, European Journal of Organic Chemistry. So your manuscript is not fit for that journal. You should look for a broad scope journal where the synthesis and medicinal chemistry is important, or the journal has a focus on medicinal chemistry. For example, ChemMedChem. So in this way, you have to look at each journal's scope and aim, and then finally you should decide a journal. So then also is a manuscript of minimum acceptable quality. So you should look at the language. You should look if the content and writing is good enough for reviewing. This is very important. Because if your message is not clear, if the writing is not good enough, then reviewers will not be able to understand what you are trying to say, what this manuscript is all about. So then it is very difficult, and then the manuscript will get direct rejection. Then significance of the research. So is your research incremental in the nature? So incremental means it is very similar to the previous works. So if your manuscript is very similar to the previous works, then it is also possible that the manuscript may receive the direct immediate desk rejection. So there should be some advancement in the field. There should be some significant advancement which you are making in the research. So will it be of interest to the readership? This is something which we also check for our journals, that it should be of interest to the whole readership or to the most of the readership of the journal. Then is the ethical guidelines followed, as I already told about plagiarism and the ethical misconducts. So this is also a very important criteria, and this is the most common reason for manuscripts getting rejection, because because ethical guidelines are not followed in the paper. So an editor check all these things, and then an editor takes a decision. For example, either to directly reject a manuscript, or to offer a transfer to another suitable journal, or to reject with re-invitation. So sometimes if the writing is not good enough, but the science is good, then we also ask the author to rewrite the paper and submit the paper again. All right. Okay, so back to the different components of the paper. I will talk about the title first. So tell your readers what your paper is all about. So title is very important. You need to include the keywords in the title. And when we first send the manuscript to a reviewer, so we just send the title and abstract. And then reviewer goes through the title and abstract, and then the reviewer decide if the manuscript, am I audible?
Yes, yes,
Yes,
you are.
yes.
Okay, okay. Yes, so the title, so be descriptive, be specific, be concise, include keywords, and avoid abbreviations or acronyms. So it is important that you should choose the title carefully. It should include a lot of keywords, because when we send the manuscript to a reviewer, first we just send the title and abstract. And then reviewer goes through the title and abstract and decide whether to review this manuscript, whether to accept our invitation to review, or whether to decline it. So it is very important. Then I will just give you this example. So suppose if the title is effect of metal catalyst on the outcome of coupling reactions with aryl alcohols. So this is a title. Now the problem with this title is that we do not know what effect authors are talking about. We do not know which metal catalyst. We do not know which coupling reaction, and we do not know which aryl alcohols. So you see that this title is not very informative. It is not very informative. So the appropriate title would be ruthenium trichloride catalyzed CH alkylation of 2,4-disubstituted aryl alcohols. So now we know which metal catalyst, we know CH alkylation, which coupling reaction, we know 2,4-disubstituted aryl alcohols. So this title is specific, it is concise, and it contains many keywords. So in this way, you have to choose a title. Then abstract. So abstract is like an advertisement of your paper. This is very important. You just have 20 seconds to explain your work to someone who is unfamiliar with your work. So it is not that always editors are familiar with your work or completely familiar with your work. Of course, they are familiar, but it is not possible to be completely familiar. Then we have the reviewers who will go through your paper. So you just have 20 seconds. So what should you need to do? The abstract should awaken the editors or readers' curiosity about the paper. So your paper, so you should write an interesting abstract so that it awaken the editor's curiosity. Then briefly place the work in proper context. Explain the key findings, main findings of your work and their significance. It should contain several keywords to ensure discoverability. Again, so that readers or the audience, they should be able to find your article, and they should be able to cite your article. And then it should be standalone. So avoid things that need context to understand. So for example, if you write in your abstract something like compound 5 has shown significant anti-cancer activity. Now, readers do not know what is compound 5. So it is important that you write, for example, you can write benzimidazole derivative 5A is showing anti-cancer activity. So you need to give you need to take care of these things. So this is an example. I'm not going to read the whole text here, but there are two parts. What has been done, so that should consist the first part, and what are the main findings. So these are the two important things that should be included in the abstract. What has been done and what are the main findings. Then I will talk about the introduction. So introduction can be easily described by the three words starting with letter I: inspiring, informative, interesting, and it should not be incredibly long. So what are the 4 parts of the introduction? First, the background. So the research area, why it is important, why you are choosing this topic, and what is the problem? What is the problem in this research area? What is the problem that you are addressing? Then any previous work on the topic. So what has already been done to address this problem? So previous studies. Then the main limitations of the previous work. So the main limitations, what are the problems with the previous studies, what they were not able to find, and then what you hope to achieve. What are you achieving from this research, from your research? So here are some examples. For example, here is a title. Here is the introduction, first paragraph. Grubbs catalysts have received increasing attention from researchers in the last couple of years, and so on. So Grubbs catalyst. Now we do not know what is Grubbs catalyst. So the better introduction would be Grubbs catalysts are ruthenium-based carbene complexes that are used in the synthesis. So here they are defining what are Grubbs catalysts. So this is low information, and this is the high information introduction. Then ketone G is found in many natural products and has interesting biological activity. Again, found in many natural products. It is not very specific. Whether you can say that ketone G is isolated from this group of plants and is an anti-cancer agent. So interesting biological activity, but here it is specific that it is an anti-cancer agent. Group Y is one of the most common, attractive, or useful. So this is the common language, and but again, this is not very useful. We do not know why group Y is important. So group Y has been applied in solar cell research because. So this is the high information density introduction, starting of the introduction, whereas this is more beating around the bush. Then next is the keywords, so which is used for the indexing and searching purposes. So they should not be too narrow or too broad. So for example, if you choose heterocycle as a keyword, now heterocycle, I would say it is a very broad keyword. Whereas if your work is, if you try to be a bit more specific, so not the IUPAC name of a compound, but for example, benzimidazole, benzoxazine, so something like this. Then avoid abbreviations. So NMR, SEM, TEM, please avoid these abbreviations. It is always good to write the whole word. Then check the guide for authors. So author guidelines, you can easily find them each journal's homepage. So find them and then study that what keywords we are looking for or what keywords you should try to include. Then the methods. So how problem was studied. So the most important thing about method is that a person skilled in the art should be able to reproduce the experiment. So there should be sufficient details in the experimental part that anyone can repeat the experiment. Then, however, use references and supplementary materials to indicate the previously published procedures. If the procedures are previously known, then you can include the references and you can include the procedure in the supplementary material. Do not need to include that in the main text. Then do not repeat the details of established methods. If some methods are very well established, then you can just give a summary and reference is sufficient rather than repeating the whole procedure. So these are some of the things that you need to take care about the method section. Okay, then the next is results. So what have you found? What have you found from your studies? So first of all, tell a clear and easy to understand story, and results should represent results only. So in the results section, if it is a table, optimization table, then it should be just a optimization table. You should not try to include the conclusion, or you should not try to infer the discussion in that section. Be structured. Do not discuss or infer conclusions from results in this section. Do not hide data in hope of saving it for a later paper. So this is very important. Sometimes authors are involved in salami slicing. So which means that authors try to divide the work in various parts just to get the more number of publications. So this is unethical, and also maybe you are able to publish your first paper, but then you will not be able to publish the rest of the paper. Even if it will be difficult to publish your first paper also, because you are hiding something, so you may lose evidence to support your conclusions. So do not try to hide the data for the future publications. So you should focus on scientific rigor than on numerical outcome. So instead of more papers, one good paper should be your focus. So then results, do's and don'ts. So use figures and tables to summarize data. And if you have involved any statistical studies, then please show the results of a statistical analysis. Do not duplicate data among tables, figures, and text, and use graphics to illustrate data that can easily be summarized with text. So please do not use, there should not be repetition. So if it is a graphics, it is fine, but then you should not write it in the text. Or if it is written in the text, then you should not include it as a graphic. So discussion, what are the results mean? So this is very important, the discussion part. So first thing is that how the results relate to studies, aims, and hypothesis. So whatever assumptions you made in the beginning, so how the results relate to that, how the findings relate to those of other studies. So it is important to talk about other studies, what has been done in the field, and how your studies are different or similar, or if you found the same thing or different things. So these relative studies, relative comparisons should be done. Then you should try to interpret your work, all the findings, all possible interpretations of your findings. Then limitations of the study. So if there is a limitation of your study, do not hide it. Please talk about the limitations. Do not avoid making grand statements that are not supported by your data. So this is very important. So do not make any statements which are not supported by the experiments or by the citation or by the data. Then also avoid introducing new results or terms in the discussion. So when you have already not talked about something, do not try to include any new result or new terms at the time of discussion. So what is discussion all about? It is to convince the reader that you are correct. You are basically, this is your chance to convince the reader that you are correct and you know about your work and you have proved the assumptions. So conclusion section, how the work advances the field, and the very important thing that do not repeat the abstract in the conclusion. Conclusion is different, abstract is the different. So conclusion, basically you need to, it can be divided into three parts. What have you shown? So what you have done. What does it mean for the field? So how it advances the field, and in comparison to previous studies, how you are making an advancement, and then indicate possible applications and extensions. So talk about future perspective. What could be the future applications? What you are intend to do further with these studies? So these kind of things can be included in the last part of the conclusion. Okay, then the next thing is references, which is also a common place for making a lot of mistakes. So please avoid over-referencing. Do not include too many references. For a full article, 25 to 30 references are more than sufficient. Then try to aim for a good balance between the original first studies and the recent findings. So there can be a field which is very well known and which has been there from last 20 years. For example, click chemistry. It is very well known. And there are several initial papers and then there are several recent findings. So then the important thing is to include some initial studies and then to include some recent findings which are related to your work. So do not miss any important related manuscripts. And if your work is based on someone else's studies, it is very important to include that in the references. And also, if it is very similar, then you need to include that in the paper also, in the manuscript. So recheck references before submission, because you may have deleted something, you may have included some new sentences. So things change when you are writing the paper. So recheck references before the final submission. So then I will talk a bit about why spending more time on graphics. So graphics are also important. Good graphics make a difference to your paper because they create a good first impression of your paper. They make the scientific message of your paper easy to understand, and they can help speed up publication. Because if sometimes graphics are not clear, then we will send the paper back to the authors to make it more clear, and it takes time. So it is better that you do it initially. So do not use a vastly different font size. Then using a single labeling style throughout improves the overall attractiveness of the paper. So it creates an overall good impression if you take care of these small things in the graphs. Then avoid use of shadows, glows. So you can see the example here. The figure on the right hand side is much more clear as compared to the figure on the left hand side. Then it is good to provide a graph which has good resolution. So graphics must be legible for an article to be considered for publication. So this figure which is provided in 300 dpi is the ideal resolution. Cover letter. So this is one area where authors usually ignores to write a cover letter, or they simply write that the paper is about this topic and I hope that you find it publishable. So this is not the purpose of the cover letter. Cover letter is your chance to speak to the editor directly. So you need to include the main findings, and remember that in the cover letter, you can include something which is not included in the paper. You can talk about the importance of the work, the possible applications. So you can tell why your manuscript is special, and you can also indicate, which is very important, approval of all authors before submission. Then experimental section and supporting information. So here the most important things to check the guidelines for the required data. So for example, for Wiley journals, we require for an organic synthetic paper, we require 1H and carbon 13C spectra to verify the purity. And we also need the HRMS or elemental analysis. So you can write it as you do your experiments continuously, which is important. Okay, so then the next is table of contents entry. So again, this is the part which authors ignore normally, which authors ignore sometimes. So again, it is important to provide the table of contents entry. It should have one graph which summarizes the results of your paper, and then it should have some text which talks about the main highlights of your paper. So for example, in this case, in the present study, mechanochemistry was applied to synthesize 3 iodobenzofurones. So here, this is about, the important thing is about mechanochemistry, and that the synthesis is about 3 iodobenzofurones. And then they also talk about the yield and the electrophilic cyclization reaction. So the main highlights of the work should be included. So I hope by this presentation, I was able to tell you what is a good manuscript, what are the main reasons for the direct rejection, and how should you write the paper, how can you improve writing your paper. And these are some of the resources. So some of the books which are about writing manuscript. Then we have Chemistry Views, which is published by Wiley, which provides tips for writing scientific papers. So please go through these resources And I hope that that my presentation was helpful for the students. Thank you very much, and I will be happy to answer any questions.
Thank you so much, Khushbu. This was really a very informative lecture. Like we always write manuscript, but we don't know what are the parameters which we should really take care of, and we should avoid any kind of plagiarism in the manuscript. Like I have a question. Like you talked about the graphs, the quality, and even like if somebody is getting a data and he is preparing that compound again, and because the compound is same and he recorded the data, he is getting the same data, he want to put that data in the manuscript, but he has repeated the data is new, but because it's the same compound, will get the same data. So can we put in the paper, will it come under the plagiarism, because we are repeating the data? In earlier paper we had the same data, in the new manuscript we are putting the same data, but we repeated it, but we use the same software to plot it. So will it come under plagiarism, or is it fine to put the same data? What is your view about this?
Yeah, so see, plagiarism, we check it from the authenticate software, but one has to look at the report. So if the plagiarism is found in the experimental section, so when you have the same data, so one is NMR would be same, 13 carbon would be same, all these things would be same. So in that case, we will not consider it as a plagiarism. So we do check the report, and on the basis of the report only we decide if something is plagiarized or it is not plagiarized. If there is some overlap in the introduction, we consider it as a plagiarism. If there is an overlap in the results and discussion section, we consider it as a plagiarism. But if you are repeating, if you are making the same compound for any studies, so there should be some purpose, like if you are synthesizing the compound and you are studying some other studies which have not been done previously, then it is fine. Then the data would be same, and it is okay. But if there are no other advancement, and if then at that time if the data is same, then we will consider it as a not as a plagiarism, but we'll consider it as incremental in nature, that it is very similar to previous studies without any significant advancement. So it really depends on the paper, what you are trying to do in the paper. Yeah.
Okay, thank you. And is there any software or like some app to decide which journal is better for your paper? Like in some of the publishing house, I have seen that they have some kind of software. We can use that software and we can find out which journal can be suitable for your work. So it's very helpful. So do you have such thing in Wiley to decide which journal is better for your work?
Yeah, I think we do have something. I'm not sure if we have an app, but if you go and just search in the net that which journal is suitable for the publication in Wiley, then you will definitely see the web, and you will find some information about how to choose a right journal for your article. So you will definitely find these. There could be a webinar, or there could be some information which is about writing, how to choose a right journal. So there will be something about from Wiley as well, but I'm not sure if we have an app. I will need to find it out.
Okay. And like one more question, like you talked about keywords, which is very important. It should not be very broad, as you mentioned, but sometimes like some journal has some list of abbreviation or some list of keywords, and we have to choose within that words only. So like it's the kind of homogeneous catalysis, for example. So is it better to put homogeneous catalysis in the keyword, or a very specific work that we are doing in catalysis? Which one is better? Because I have seen many journals, they have homogeneous, heterogeneous, and we are forced to put this broad keyword. So which one is better? Like it should be broad like this, homogeneous, or it should be specific?
Yeah, I think that, so as I mentioned that maybe not the IUPAC name of the whole catalyst, not in that way, but if it is like ruthenium based, so you can write ruthenium catalysis, ruthenium homogeneous catalysis, or ruthenium catalyzed reaction. So, or ruthenium catalyzed simply. So ruthenium, rhodium. So I think these words are more better than using a very broad keyword like homogeneous catalysis, because then there will be so many papers about homogeneous catalysis that it will not be specific. So be little specific, but it should not also be like a whole name, IUPAC name of the catalyst.
Okay. And like one more thing you mentioned, Wiley is now, Wiley has a new journal for women also. And just a suggestion, like to increase the papers or the manuscript of the women scientists, like you can see the comparison, the women scientists are less involved in research. Maybe at initial stage they are involved, but on later stage you will see we have less number of female scientists. So to increase their papers in Wiley, can we have such type of facility like for some journals or special issue like article processing charge or APC that can be waived off for the women? If the main corresponding author is a woman scientist, so we can waive off the charges for open access.
First, I would need to correct one thing, that we do not have a new journal for women scientists, but we are publishing the special collections or special issues dedicated to women scientists. So one special issue, for example, dedicated to Asian women in science, or one is just for the women in science, women in chemistry kind of. So we always do these special issues. Regarding the for the open access journals, so we sometimes do waive off the charges, but we have not thought about especially for women corresponding authors. We just do it sometimes for a particular country, or sometimes when we are launching something special, or at some special occasions we do that, but we have not thought about it. But thanks for the suggestion, and I will talk in Wiley about this suggestion, that if we can do, it's a great idea. So let's see. Yeah.
Okay, thank you so much. And there are many more questions, but like we have to run another session now. So thank you so much, Khushbu. Now I invite Dr. Sushila to present memento and certificate of appreciation through Dr. Khushbu. Dr. Sushila.
Ma'am, please stop sharing your screen. Khushbu ma'am.
Okay.
You may get an option either at the top or bottom, stop share.
Yes, stop share. Okay. Yeah, I have stopped sharing.
Yeah, Dr. Sushila.
Dr. Sushila,
Professor
you are
Sushila.
not audible. Dr. Sushila. Thank you so much, Khushbu. Dr. Leena, could you please share the e-memento and certificate of appreciation? Thank you so much, Dr. Khushbu, for sparing your precious time. I know you are very busy, so kindly accept the e-memento and certificate of appreciation. Thank you so much.
Thank you so much. Thank you so much. And again, for inviting me to deliver this lecture. It is a pleasure. So thank you.
Yeah, thank you so much. Over to Dr. Leena. Dr. Leena.
Yes. Thank you, Khushbu ma'am, for such a nice talk on writing great manuscript. I have learned many important things that we should keep in mind while writing the manuscripts, and that we will implement obviously in our new manuscripts. I would also thank Sushila ma'am and Pratibha ma'am for chairing the session and for taking up the question and answer session. Now, without any delay, we will start with the e-poster session. I would like to invite Dr. Ashwini Singh for discussion on e-poster presentation.
Dr. Ashwini.
Thank you.
Over to you,
Thank you, Lina ma'am. Thank you, Lina ma'am. Am I audible? Are you hear me?
Yes, you are audible.
Okay. Idea which comes from many directions can change the path. For example, Newton get idea below the mango tree, and Kekulé, great organic chemist, get the idea from his dream. Many of us get it yesterday in poster presentation session, and today I, Dr. Ashwini Kumar Singh, Assistant Professor on the behalf of Department of Chemistry, Deshbandhu College, Delhi University, welcome to all of you to this e-poster session. Yesterday, 68 participants from India and abroad present their poster. Trust me, there are so many wonderful and creative posters. The jury members face very tough situation during the evaluation process. But you know the serious word that is competition. Right now, I display all posters here in the form of PPT. Have a look. Dr. Lina, please share the PPT. Dr. Lina, please.
We have also considered even the effort of the BSc students of making these type of posters.
Dr. Ashwini, I think your mic is on. I request you to mute. Dr. Ashwini, yes, thank you.
Thank you, Dr. Lina. With this, we will end our session, e-poster session. I would like to thank all participants for your wonderful and significant e-posters. We will announce all the prizes in valedictory session. It is mandatory to all participants to kindly fill the feedback forms which will be floating during the valedictory session. The time for quiz. Quiz time is about 10 minutes and at 3:30 p.m. onwards. Now, I over to you, Dr. Maku Moran Singh, for the next.
Let me
I think,
take first.
yeah. Lena, yeah, can you please announce that
Yeah.
there is a lunch break and
Yeah.
ask like request everybody to like stay joined, don't leave this session. And okay, yeah.
With that, we conclude session 1 of this symposium, and all the participants are requested to please fill the feedback form after which will be shared in the chat box in between session 2. The link will be shared in the chat box, so please fill up that link because then only the e-certificates will be generated. So we will have a lunch break till 1:25 p.m. and then the second session will start from 1:30 p.m. And you all are requested to please attend the second session and fill the feedback form to get the e-certificates. And the winners for the posters will be announced in the valedictory session, and the quiz will also be there after the second session.
So dear participants, it's important to attend the second session because we will be sharing feedback link in the second session. So please join the second session and don't leave your this meeting because you need not to rejoin it. You can take a lunch break, but stay connected. And we will start the session at 1:25 because at 1:30 we have another lecture. So it's important for you to attend the next lectures also because at 3:30 we will be having a quiz which is very interesting and all the questions are based on the lectures that you are listening. So it's important to listen to these talks because your quiz is based on all these talks. So don't leave this meeting, stay connected, and we all are can have a break for I think 20 minutes or 25 minutes. We will be meeting again at 1:25. Thank you so much all.
पोस्टर डिस्प्ले कर दो जो इनिशियल पोस्टर है हमारा।
हाँ सर, या तो पोस्टर या फिर वीडियो वगैरह चला के छोड़ सकते हैं।
हाँ वीडियो चला दो, वीडियो चला दो।
मैम डॉक्टर लीना मैम, please you share again poster.
I will share.
Yeah, because some student asking.
Anyone is sharing or should I share?
You share it, Dr. Lina.
You share, हाँ, Dr. Lina.
Please stop sharing this. Who one is sharing? Seema ma'am?
Okay, I done it.
Lina, Dr. Lina, please unmute. Sorry, mute yourself. Dr. Lina.
नहीं, वो सुबह सुबह तो मेरा था बोलेगा ना।